Introduction. Most of the substances around us undergo changes. Some of these changes can be temporary, with no new substances being formed. They are called physical changes. In certain other changes, new substances are formed and the parent substance loses its identity. In such changes, we cannot get back the original substance from the new substance by simple means. They are called permanent changes. For example, burning of paper to yield carbon. When paper is burnt, black particles of carbon, ash, is formed. Now it is not possible to get back paper from it. This is a permanent chemical change. Objectives. At the end of this lesson, you'll be able to recognize chemical changes, write equations to represent a chemical reaction, classify chemical reactions, list examples for different types of chemical reactions. Chemical reactions. A chemical reaction is that in which a substance or substances react chemically to form a new substance or substances. The substances that take part in a chemical reaction are called reactants. The new substances which are formed are called the products. Iron plus sulfur gives iron sulfide. Iron and sulfur are the reactants and iron sulfide is the product. When sugar is heated, it gets charred. The water molecules in the sugar leaves behind carbon. Writing a chemical equation. In a chemical reaction, the reactants, one or more, react together and form a new compound known as the product. For example, aluminium oxide reacts with dilute sulfuric acid to form aluminium sulfate and water. The reaction can be written as aluminium oxide plus dilute sulfuric acid gives aluminium sulfate and water. The following steps are followed to write a chemical equation. Symbols and formulae of reactants are written first on the left-hand side. If there is more than one reactant, then a plus sign is placed between the different reactants. Aluminium oxide and dilute sulfuric acid, for instance, are written as Al2O3 plus H2SO4. An arrow is marked after the reactants to indicate that they react to form the product. Symbols and formulae of the compounds formed, products, are written after the arrow on the right-hand side, which indicates that these are formed. Here also a plus sign is placed between the different compounds formed. For example, Al2O3 plus 3H2SO4 gives Al2SO4 3 plus 3H2O. Balancing the equation. The chemical equations are based on the law of conservation of mass. According to this law, mass can neither be created nor be destroyed in a chemical reaction. This will be possible only if the total number of each type of atom is the same on the reactant side as well as on the product side of the equation. Equations in which the number of atoms of different elements in the reactants are the same as the number of atoms on the product side are known as balanced equations. Balancing the equation. Al2O3 plus H2SO4 gives Al2SO4 3 plus H2O, equation 1. The above equation is an unbalanced one. There is only one atom of sulfur in the reactant side, while there are 3 atoms of sulfur in the product side. Al2O3 plus 3H2SO4 gives Al2SO4 3 plus H2O, equation 2. Now there are 6 hydrogen atoms on the reactant side and only 2 hydrogen atoms in product side. Multiply H2O molecules in the above equation by 3. Now the equation 2 becomes Al2O3 plus 3H2SO4 gives Al2SO4 3 plus 3H2O, which is equation 3. Now in the equation 3, the oxygen atoms are 15 both in reactant and product side. So the final balanced equation is Al2O3 plus 3H2SO4 gives Al2SO4 3 plus 3H2O. Different types of chemical reactions. Elements and compounds interact with each other to produce a variety of substances. Millions of compounds have been formed by chemical reactions between elements or compounds. Chemical reactions require different sets of conditions such as temperature, pressure, presence of light, etc. Chemical reactions occur in a variety of systems. For example, in the human body, plants, industries, nature, etc. Types of chemical reactions. Combination reaction, decomposition reaction, displacement reactions, double displacement reactions. Combination reactions. In some reactions, new matter is added to the original substance and the substance gains in mass. Such a reaction is called a combination or synthesis reaction. Combination reactions are those in which one element reacts with another to form a compound. Such reactions are also known as synthesis reactions. For example, hydrogen combines with oxygen to give water. 2H2 plus O2 gives 2H2O. 2Cu plus O2 gives 2CuO. 4Fe plus 3O2 gives 2Fe2O3. Rust. Take a magnesium ribbon and heat it over a flame. It burns, giving out a bright white light. The magnesium ribbon becomes white powder. Now add some water to the powder and put a drop of red litmus. The red litmus turns blue. This is due to combination reaction. Oxygen in the air combines with magnesium to give white powder of magnesium oxide. Magnesium oxide reacts with water to give magnesium hydroxide. Being basic, it turns red litmus blue. Decomposition reactions. Decomposition reactions are those in which a compound breaks down into simpler compounds. For example, on heating, calcium carbonate decomposes to give calcium oxide and carbon dioxide. CaCO3 gives CaO plus CO2. Water decomposes to give hydrogen and oxygen when electricity is passed through it. Take a piece of a marble. Hold it with a pair of tongs. Heat it over flame for some time. Now let it cool. Drop the solid into water. Add a drop of red litmus to the solution. The color of litmus changes to blue. Calcium carbonate marble decomposes to calcium oxide and carbon dioxide. The calcium oxide formed reacts with water to give an alkaline solution. Therefore, red litmus turns blue. Take 0.5 gram of zinc carbonate in a test tube. Fit the test tube with a cork and a delivery tube. Heat over the flame. You will see a colorless gas is given out. The gas, on passing through lime water, turns it milky. Heating zinc carbonate decomposes it to carbon dioxide gas and zinc oxide. The carbon dioxide turns lime water milky. Heat about 1.0 gram of ferrous sulfate in a china dish. On strong heating, the green color of ferrous sulfate changes to brown. A pungent-smelling gas also comes out of it. This is due to the decomposition of ferrous sulfate to give brown ferric oxide and pungent gases like SO2 and SO3. Displacement reactions. A displacement reaction is a reaction in which an atom or a group of atoms present in a molecule is displaced by another atom. For example, iron when added to a solution of copper sulfate displaces copper metal. Dissolve 0.5 gram of silver nitrate in 10 ml water in a test tube. Place a clean copper wire in the test tube. Keep it for some time. Shining crystals of silver appear on the copper wire. The color of the solution becomes bluish as some copper nitrate is formed. In this reaction, iron metal has displaced copper from the solution of copper sulfate. Take copper sulfate solution in a test tube. Place the iron nail in the copper sulfate solution and keep it for some time. After some time, the blue color of the solution fades and red-colored copper metal is displaced from the copper sulfate solution. The displacement reaction which occurs is Fe plus CuSO4 gives FeSO4 plus Cu. Some other examples of displacement reactions are 2Na plus 2H2O gives 2NaOH plus H2. 2Al plus Fe2O3 gives Al2O3 plus 2Fe. Double displacement reactions. Double displacement reactions are those in which two compounds exchange ions to form two new compounds. These reactions are also called partner exchange reactions. These reactions occur in ionic compounds. For example, in the reaction of copper sulfate and hydrogen sulfide, copper sulfite and sulfuric acid are formed. Thus, the partner of copper is exchanged for the partner of hydrogen in hydrogen sulfide. The reaction of barium chloride and sulfuric acid to form barium sulfate is also a double decomposition reaction. The neutralization reactions are also double decomposition reactions. Redox reaction. Redox reactions are those in which oxidation and reduction takes place at the same time. In these reactions, one substance is reduced while the other is oxidized. Activity. Take a china dish and add a small amount of copper powder and heat it. What happens to copper powder? The surface of copper powder has changed to black color. This is because oxygen has combined with copper and copper oxide is formed. If hydrogen gas is passed over this heated material, CuO, the black coating on the surface turns brown as the reverse takes place and again copper is obtained. Cupric oxide changes into copper. Oxygen is thus removed from cupric oxide. Since removal of oxygen is reduction, cupric oxide is reduced to copper. Hydrogen removes this oxygen from cupric oxide. Hence, hydrogen is the reducing agent. Thus, oxidation and reduction occur simultaneously. For example, sodium gets oxidized when it changes to Na+. Oxidation is defined as the gain of oxygen or loss of hydrogen or loss of electrons by a substance. Reduction is defined as the gain of hydrogen or loss of oxygen or gain of electrons by a substance. Zinc gets oxidized to Zn2+ when a zinc rod is dipped in a copper sulfate solution. In this reaction, zinc has lost 2 electrons to become Zn2+. Thus, zinc gets oxidized. On the other hand, Cu2+ gets reduced as it accepts 2 electrons released by Zn to become Cu. Corrosion. You might have noticed that old iron gates turn reddish-brown in color. The turning of iron materials into reddish-brown color is rusting of iron. Some other materials also tarnish the same way. The black coating on silver and the green coating on copper are other examples of corrosion. Corrosion is the process by which metals are eaten up gradually by the action of air, moisture, or a chemical on their surface. Rancidity. If a metal is reactive, its surface may be attacked slowly by the action of oxygen and water in the atmosphere. The metal reacts with the oxygen of air and water vapor of air, forming compounds on its surface. The formation of these compounds tarnishes the metal, that is, it makes the surface of the metal appear dull. The compounds formed on the surface of metal are usually porous and gradually fall off from the surface of metal, and then the metal underneath is attacked by air and water. The process goes on and on. In this way, the action of air and water gradually eats up the whole metal. When we keep food materials containing fat or oil for a long time, we get an unpleasant smell and the taste also changes. This is because the food materials get rancid. Rancidification is the decomposition of fats and oils by hydrolysis or by oxidation. Antioxidants are often added to fat-containing foods in order to retard the development of rancidity due to oxidation. Natural antioxidants include polyphenols, ascorbic acid, tocopherols. Synthetic antioxidants are butylated hydroxyanisole and butylated hydroxytoluene. Rancidification can be prevented to some extent by keeping food in refrigerators, by storing food away from sunlight and in airtight containers, by filling the nitrogen in packaging food materials. The nitrogen gas prevents the food material from being oxidized and thus prevent rancid. Did you know? A solution of slaked lime produced by the reaction is used for whitewashing walls. Calcium hydroxide reacts slowly with the carbon dioxide in air to form a thin layer of calcium carbonate on the walls. Calcium carbonate is formed after 2 to 3 days of whitewashing and gives a shiny finish to the walls. It is interesting to note that the chemical formula for marble is also CaCO3. Summary. Let us summarize what we have learned. Chemical reactions are permanent changes. Each chemical reaction can be represented by a balanced chemical equation. The different types of chemical reactions discussed are combination reactions, decomposition reactions, displacement reactions, double displacement reactions, redox reactions.
Introduction. Gaurav, please take care when you mix water with the acid. Keep stirring the acid while you mix.
Why is that, teacher? Why can't I mix them directly? It will take so much time.
Yes, I agree that it will take time, but you have to mix them slowly, else you might get burned.
Oh yes, I feel the container hot. Why is it so?
Let me tell you, it is because of the reaction between acid and bases. Children, in this lesson we will learn about the chemical properties of acids and bases and about salts. Objectives. At the end of this lesson, you will be able to describe the chemical properties of acids and bases, identify the common properties of acids and bases, describe the strength of acids and bases, explain salts. The chemical properties of acids and bases. An acid is a substance that produces hydrogen ions when added to water, whereas a base is a substance that produces hydroxide ions when added to water. Both acids and bases have different chemical properties. Let us look at their properties. Olfactory indicators. Suppose you are given 4 chemicals and asked to identify them as acids or bases. How will you do it? Let us find out. We have olfactory indicators which indicate whether a particular substance is an acid or base due to change in their smell. They are used in the laboratory to test whether a solution is a base or an acid by a process called olfactory titration. An olfactory indicator works on the principle that when an acid or base is added to a substance, then its odor cannot be detected. For example, the juice of the red cabbage. This liquid has a blue-violet color, but when it comes in contact with acidic substances, it becomes red, and when it comes in contact with base substances, it becomes green and even yellow. Did you know? Every liquid you see will probably have either acidic or basic traits. Water, H2O, can be both an acid and a base. It can be considered an acid in some reactions and base in others. Water can even react with itself to form acids and bases. Reactions of acids and bases. Let us go back where Gaurav felt the mixing beaker hot. When acid is mixed with base, it produces heat. This may cause the mixture to splash out. This may cause you burns. Also, the glass container may also break because of excessive local heating. So we must be careful while handling acids and bases. Let us look at the different reactions of acids and bases with metals, metal carbonates, and metal hydrogen carbonates, and with each other. Reaction with metals. All metals above hydrogen in the reactivity series react with dilute acids to form their respective salt and free hydrogen. Active metals such as potassium, sodium and calcium also react similarly but explode when combined with acids. Reaction with metal carbonates and metal hydrogen carbonates. Acids react with carbonates and hydrogen carbonates to form their respective salt, water and carbon dioxide. Reaction with each other. Acids and bases are the chemical opposites of each other. The action of an acid and a base nullifies the effect of one on the other. This is known as neutralization reaction. In this reaction, an acid combines with a base and forms a molecule of water and the respective salt. Reaction of metallic and non-metallic oxides. Now that you have seen how acids and bases react with metals, hydrogen carbonates, and with each other, let us look at how acids react with metallic oxides and bases react with non-metallic oxides. Reaction of metallic oxides with acids. Oxides that add on hydroxyl ions to their molecules are called basic oxides. These oxides get neutralized when they react with acids. Acids undergo neutralization reaction with basic hydroxides to form salt and water. Reaction of non-metallic oxides with bases. The reaction of calcium hydroxide with carbon dioxide produces salt and water. This reaction is similar to the reaction between a base and an acid. This proves that non-metallic oxides are acidic in nature. Did you know? When an acid and a base react with each other, they form water. The acid gives away an H+ ion and the base accepts it by bonding it with the OH ion. This is why an acid is called a proton donor and a base is called a proton acceptor. Reaction with water. When acids are mixed in an aqueous solution, they produce ions. When dissolving an acid or a base in water, you have to remember that it is a highly exothermic process. While adding water to a concentrated acid, keep in mind that the heat generated may cause the mixture to splash out, which leads to burns. This may lead to the glass container breaking due to excessive local heating. When you mix an acid or base with water, it results in decrease in the concentration of ions per unit volume. This process is called dilution and you get diluted acid or base. Strength of acids and bases. You need to use a universal indicator to find the amounts of ions present in a solution or to find out how strong an acid or base is. The universal indicator is a mixture of several indicators. It shows different colors at different concentrations of hydrogen ions in a solution. A pH scale is a scale of measuring hydrogen ion concentration in a solution. You can measure pH from 0, which represents very acidic, to 14, which represents very alkaline. Neutral elements have a pH value of 7. Did you know? The chemical properties of all acids are similar. You know that hydrogen gas is released when acids react with metals. This proves that hydrogen is common to all acids. However, you need to find out if all elements that contain hydrogen have acidic properties. Importance of pH in everyday life. Let us look at some examples from our day-to-day life where pH forms an integral part. The pH of the soil. The pH of the soil or soil reaction indicates the acidity or alkalinity of soil. It is measured in pH units. It is defined as the negative logarithm of the hydrogen ion concentration. With the increase in the amount of hydrogen ions in the soil pH also increases, leading to being more acidic. Soil pH is considered to be a master variable in soils because of the control it has on the many chemical processes that take place. It specifically affects plant nutrients availability by controlling the chemical forms of the nutrient. The pH in the digestive system. Our stomach produces hydrochloric acid, which helps in the digestion of food without causing any harm to the stomach. When the stomach produces too much acid, it leads to indigestion and causes pain and irritation. The solution to this pain is the use of bases called antacids, which neutralize the excess acid. The pH change as the cause of tooth decay. The cause of tooth decay is the corrosion of the tooth enamel. This tooth enamel, made up of calcium phosphate, is the hardest substance in our body. It is not soluble in water but gets by acid, and when the pH is below 5.5. The bacteria present in our mouth produce acids by degrading sugar and food particles that are left in the mouth after eating. To prevent this, clean the mouth after eating food. Also, using toothpastes, which are basic, neutralizes the excess acid and prevents tooth decay. Did you know? Animals and plants release acids in self-defense. For example, a bee stings by a nettle plant. These are self-defense mechanisms developed by nature for plants and animals. Family of salts. Salts are formed from the reaction between acids and bases. It is produced when the H+ ion of the acid is replaced by a metal ion or by the ammonium ion. Salts with the same positive or negative radicals are said to belong to a family. For example, NaCl and Na2SO4 belong to the family of sodium salts. Similarly, NaCl and KCl belong to the family of chloride salts. pH of salts. Here is the pH of salts. A strong acid and a strong base pH value of 7. A strong acid and a weak base pH value less than 7. A strong base and a weak acid pH value more than 7. Chemicals from common salts. The following are some of the chemicals produced from salts. Common salt. Common salt with the chemical name of sodium chloride is an ionic compound with the formula NaCl. It is responsible for the salinity of the ocean. It is commonly used as a condiment and food preservative since it is the major ingredient in edible salt. Sodium hydroxide. Sodium hydroxide, commonly known as caustic soda, has a molecular formula as NaOH. It is a highly caustic metallic base available in pellets, flakes, granules, and as a 50% saturated solution. It is soluble in water, ethanol, and methanol. It is used as a strong chemical base in the manufacture of pulp and paper, textiles, drinking water, soaps and detergents, and as a drain cleaner. Bleaching powder. Bleaching powder, with the chemical name of calcium hypochlorite, is a chemical compound with formula CaClO2. It is used mainly for water treatment and as a bleaching agent. It is relatively stable chemical and has greater chlorine available than sodium hypochlorite. Baking soda. Sodium bicarbonate or sodium hydrogen carbonate, commonly known as baking soda, is the chemical compound with the formula of NaHCO3. It is a white solid that is crystalline but appears as a fine powder. It has a slightly salty alkaline taste. Washing soda. Sodium carbonate, commonly known as washing soda or soda ash with the chemical formula of Na2CO3 is a sodium salt. It is domestically well known for its everyday use as a water softener. It can be extracted from the ashes of many plants. It is synthetically produced in large quantities from salt and limestone. Did you know? Water of crystallization is the water that occurs in crystals. It is necessary for the maintenance of crystalline properties but capable of being removed by sufficient heat. It is the total weight of water retained by certain salts at a given temperature. Summary. Let us summarize what we have learnt. An acid is a substance that produces hydrogen ions when added to water, whereas a base is a substance that produces hydroxide ions when added to water. Olfactory indicators indicate whether a particular substance is an acid or base due to change in their smell. Every liquid you see will probably have either acidic or basic traits. All metals above hydrogen in the reactivity series react with dilute acids to form their respective salt and free hydrogen. Acids react with carbonates and hydrogen carbonates to form their respective salt, water, and carbon dioxide. Acids and bases are the chemical opposites of each other. When acids are mixed in an aqueous solution, they produce ions. A pH scale is a scale for measuring hydrogen ion concentration in a solution. Salts are formed from the reaction between acids and bases.
Introduction. Arun, do not put that nail in the plug. You will get an electric shock. Why, teacher? It is a rusted nail and of no use to us. Though the nail is rusted, it is a metal, that is, a good conductor of electricity. If you put that in the plug, it will give you a shock. Oh, you saved me! Children, in this lesson we will learn about metals and non-metals, the chemical and physical properties of metals, the extracting of metals, and the corrosion of metals. Objectives. At the end of this lesson, you'll be able to describe the physical and chemical properties of metals and non-metals, identify how metals and non-metals react, explain the occurrence of metals, describe corrosion. Physical properties. Metals. You come across a lot of metals and non-metals in your day-to-day life. For example, the hammer that you use to fix nails is a metal. The nail made of iron is also a metal. Let us look at the physical properties of metals. The physical properties of metals are: physical state. Metals are solid at room temperature. For example, iron, aluminium. Only mercury is liquid metal. Good conductors of heat and electricity. Metals are good conductors of electricity as they have free electrons. For example, silver and copper are the best conductors of heat and electricity, whereas lead is the poorest conductor of heat. Malleable. Metals can withstand hammering and be made into thin sheets known as foils. For example, iron is heated and then hammered into different forms, foils, shapes, etc. Ductile. Metals can be drawn into wires. For example, 100 gm of silver can be drawn into a thin wire of about 200 meters long. Luster. Metals reflect light from their shiny surface. They can also be polished. For example, gold, silver, and copper are metals with a shiny surface and can be polished. Physical properties. Non-metals. Let us now look at the physical properties of non-metals. Physical state. Non-metals exist in as solid, liquid, or gaseous in state at room temperature. Gas, oxygen, chlorine, fluorine. Liquid, bromine, and solid, carbon. Non-malleable and non-ductile. Non-metals are brittle and cannot be rolled into wires or beaten into sheets. Poor conductors of heat and electricity. Non-metals are poor conductors of heat and electricity. Graphite, carbon, is an exception as it is a good conductor of electricity and is used in making electrodes. Luster. Non-metals have no metallic luster and do not reflect light. Did you know? Metals are solid at room temperature. The only exception is mercury, which is liquid. Mercury, the liquid metal, conducts heat and electricity as well. It is very dense. Mercury is very poisonous. Non-metals are poor conductors of electricity. However, graphite, which is a form of carbon, is a good conductor of electricity. Chemical properties of metals. Let us look at some chemical properties of metals. These properties include reactions of metals with other elements, that is, air, water, acids, and other metal salts. With air. When metals come in contact with air, they form metals oxides. There are some metals that show both basic and acidic properties. Such metals are called amphoteric oxides. With water. When metals come in contact with water, they form metal hydroxides and hydrogen. Metal make the water become a metal hydroxide solution. With acids. Metals react with dilute acids to form salts and hydrogen. This reactivity varies from metal to metal. However, when metals react with nitric acid, hydrogen gas is not formed as this acid is a strong oxidizing agent. With solutions of other metal salts. A more reactive metal displaces a less reactive metal from its salt solution. To put in simple words, if metal A displaces metal B from its solution, metal A is more reactive than B. However, not all metals are reactive. In this reaction, the copper contained in the copper sulfate is replaced by zinc. The reactivity series. Metals being arranged in the decreasing order of their reactivity is called a reactivity series. It is used to summarize information about the reactions of metals with air, acids, and water. How do metals and nonmetals react? Metal atoms have 1 to 3 electrons in the outermost shell, whereas nonmetals atoms have 4 to 8 electrons in the outermost shell. Exception. 2 exceptions to this rule: hydrogen and helium. Metals that donate electrons gain positive charge equal to the number of electrons donated, and nonmetals gain electrons and negative charge equal to the number of electrons accepted. When a metal atom donates 1, 2, or 3 electrons from its valence shell to another nonmetal atom that has the ability to accept these electrons, it is known as electrovalency. As a result of this, both these atoms form the structure of an inert gas. The transfer of electrons from the atom of an element to the atom of another is called an ionic compound. Properties of ionic compounds. Let us look at some ionic compound properties. Physical nature. Ionic compounds are hard solids as the force of attraction between the positive and negative ions is very strong. These compounds are brittle and break when pressure is applied. Melting and boiling points. Ionic compounds have high melting and boiling points because of a considerable amount of energy that is required to break the strong inter-ionic attraction. Solubility. Ionic compounds are soluble in water and insoluble in solvents such as kerosene, petrol, and so on. Conduction of electricity. Ionic compounds, when in solid state, do not conduct electricity as the movement of ions is not possible because of the rigid structure. But when ionic compounds are in a molten state, it is possible to conduct electricity as the electrostatic forces of attraction between the oppositely charged ions are overcome due to the heat. This leads to ions to move freely and conduct electricity. Did you know? Positive to positive and negative to negative ionic bonds do not occur, just as the similar poles of a magnet repel. Occurrence of metals. Extraction of metals and ores. Earth is the major source of metals. However, seawater also contains some soluble salts. Minerals are the elements or compounds which occur naturally in the Earth's crust. Sometimes minerals contain a very high percentage of a metal. This metal can be extracted from it. Such minerals are called ores. Ores are impure metals that contain a large amount of sand and rocky material. These impurities in the ore are called Gangu. These impurities have to be removed from the ore before the metal is extracted. Once the impurities are removed, the ore is in a concentrated form. This concentration of the ore is also known as enrichment of ore. Extracting metals. After the metals are separate from their ores, they are classified based on their reactivity. The following are the various categories of metals grouped as per their reactivity. Extracting metals low in the activity series. Metals that low in the activity series are very unreactive. The oxides of these metals are reduced to metals by heating alone. Extracting metals in the middle of the activity series. The metals in the middle of the activity series are moderately reactive. These metals are usually present as sulfides or carbonates in nature. It is easier to obtain a metal from its oxide. Therefore, first these metals need to be converted to their oxides. The process used to convert sulfide ores by heating strongly in the presence of excess air is known as roasting. The process used to convert carbonate ores by heating strongly in limited air is known as calcination. Extracting metals towards the top of the activity series. The metals that are high up in the reactivity series are very reactive and cannot be obtained from their compounds by heating with carbon, as these metals have more affinity for oxygen than carbon. These metals are obtained by electrolytic reduction. Refining of metals. The metals produced by reduction processes are not pure. They still contain impurities, which must be removed to obtain pure metals. The most widely used method for refining impure metals is electrolytic refining. Many metals are refined electrolytically. The impure metal is made the anode and a thin strip of pure metal is made of cathode. A solution of the metal salt is used as an electrolyte. On passing the current through the electrolyte, the pure metal from the anode dissolves into the electrolyte. An equivalent amount of pure metal from the electrolyte is deposited on the cathode. The soluble impurities go into the solution, whereas the insoluble impurities settle down at the bottom of the anode. These are known as anode mud. Did you know? Silver, gold, and platinum atoms are not easily oxidized. So, silver, gold, and platinum simply fall from the anode to the bottom of the tank, where they can be scrapped up after the electrolytic refining process is complete. Corrosion. Metals that are chemically active get corroded in the presence of a moist atmosphere. Corrosion is an oxidation reaction with atmospheric oxygen in the presence of water on the surface of a metal. For example, iron and aluminium corrode. However, non-reactive metals like gold, platinum, mercury do not corrode. There are three ways to prevent corrosion. Sacrificial protection, where the more reactive protecting metal is oxidized away, leaving the protected metal intact. Alloying, where metals are mixed with other metals to make non-rusting alloys. Galvanizing, where a metal is covered in thin zinc layer. This layer is produced by electrolytic deposition. Summary. Let us summarize what we have learned. Metals are good conductors of electricity, whereas non-metals are poor conductors of electricity. Metals react with air, water, and acids. Metals being arranged in the decreasing order of their reactivity is called a reactivity series. The transfer of electron from the atom of an element to the atom of another is called an ionic compound. Metals are extracted from ores. The most widely used method for refining impure metals is called electrolytic refining. Introduction. Do you all know that the organic food that we all eat contains carbon? Carbon? But teacher, isn't that bad as it contaminates our food? No, Ramesh. Carbon has nothing to do with the pesticides or chemicals. In fact, it makes our food healthier. That is why carbon is a very important element in our day-to-day life. Children, in this lesson, you will learn about carbon, the versatile nature of carbon, the chemical properties of carbon, and a few important carbon compounds. Objectives. At the end of this lesson, you'll be able to identify the covalent bond in carbon, Explain the versatile nature of carbon. Describe the chemical properties of carbon compounds. Describe important carbon components. Bonding in carbon. The covalent bond. Carbon is the chemical element with symbol C and atomic number 6. As a member of group 14 on the periodic table, it is non-metallic with 4 electrons available to form covalent chemical bonds. A carbon-carbon bond is a covalent bond between 2 carbon atoms. The most common form is the single bond, a bond composed of 2 electrons, one from each of the 2 atoms. Carbon also has the unique characteristic to form long chains of its own atoms. This property is called catenation. The allotropes of carbon are graphite, diamond, and amorphous carbon. Versatile nature of carbon. Organic compounds are made up of carbon, hydrogen, oxygen, and a few other elements. The unique nature of the carbon atom and the arrangement of the bond carbon forms with other atoms enable formation of organic compounds. Tetravalency. Carbon is tetravalent in nature. It always forms covalent bonds by sharing electrons with 1, 2, 3, or 4 carbon atoms or atoms of other elements or groups of atoms. Strong carbon-carbon covalent bonds. Carbon atoms form a strong bond resulting in the formation of stable compounds. Carbon atoms can also form stable bonds with other atoms. Carbon-carbon multiple bonds. A carbon atom can also form multiple bonds as it is small in size. Double and triple bonds can also be formed with not only carbon, but with atoms of other elements like oxygen, nitrogen, and so on. These multiple bonds provide a variety in the carbon compounds. Saturated and unsaturated carbon compounds. Carbon forms many compounds. The 2 main types of compounds are saturated compounds and unsaturated compounds. Saturated compounds. The carbon and hydrogen compounds, where the adjacent carbon atoms contain only one single covalent bond, are known as saturated hydrocarbons. The reason for the formation of saturated hydrocarbons is because all the 4 bonds of carbon are fully utilized and no more hydrogen or other atoms can be attached to it. These are known as alkanes. Unsaturated compounds. Compounds of carbon and hydrogen that contain double or triple covalent bonds between the carbon atoms are called unsaturated hydrocarbons. These are formed as all the bonds of carbon are not fully utilized by hydrogen atoms, and more of these bonds can be attached to them. Double covalent bond unsaturated hydrocarbons are known as alkenes, and triple covalent bond unsaturated hydrocarbons are known as alkynes. Chains, branches, and rings. Many compounds contain carbon atoms and are linked with each other. The chains of carbon atoms are linear chains, branched chains, and cyclic rings. Linear chains. Tetravalency and catenation of carbon compounds allows the formation of stable chains of atoms with different chain lengths and structures. Branched chains. Carbon compounds can be branched when the carbon atoms are more than 3. Branched chains give rise to a different structure to the parent alkane. Cyclic rings. Carbon rings are rings of carbon atoms. The number of atoms to form a ring is 5 and 6 carbons. Rings of 3 and 4 are possible, however, they have a larger ring strain and are unstable. Carbon, a friend in disguise. Carbon is a friendly element. It not only bonds with hydrogen, but also with other elements such as halogens, oxygen, nitrogen, and sulfur. The compounds are formed in the same manner as with hydrogen. However, instead of hydrogen, the other element is used, and this element replacing hydrogen is called a heteroatom. A functional group is created that confers specific properties to the compound without considering the length and nature of the carbon chain. Homologous series. Homologous series is a series of related chemical compounds that have the same functional group. These differ in formula by a fixed group of atoms. The successive members of such series are called homologous. Even though the general formula remains constant in a homologous series, specific members of the series may have different structures and properties. However, the reactivity usually remains the same. In any homologous series, a gradation in the physical properties is observed. This gradation occurs due to the increase in the melting points and boiling points along with increasing molecular mass of the compound. Nomenclature of carbon compounds. The system of assigning a proper name to a particular carbon compound is called nomenclature. Most carbon compounds have two types of names. Trivial names. Trivial names are the commonly used names of carbon compounds. These are derived mostly from the source of the compound. However, names formed using this manner is ambiguous and repeating. IUPAC names. Carbon compounds now need to be named in a more systematic way. A committee called the International Union for Pure and Applied Chemistry, IUPAC, put forward a system of giving scientific names to carbon-based compounds. These names followed all over the world and are called IUPAC names. Chemical properties of carbon compounds. Carbon is a very reactive element. Main chemical properties are listed. Combustion. The burning of a substance is called combustion. It is a process that generates a lot of heat. When carbon and its compounds are burnt, heat energy, carbon dioxide, and water are produced. Oxidation. Oxidation is a process where carbon compounds are easily oxidized after combustion. After complete oxidation, additionally, we have reactions in which carboxylic acids are generated through alcohol after combustion. Addition reaction. Hydrogen is added to unsaturated hydrocarbons in the presence of catalysts and produce saturated hydrocarbons. These catalysts are substances that cause a reaction to occur or proceed at a different rate without affecting the reaction itself. Substitution reaction. Most reagents are not able to generate any reaction from saturated hydrocarbons. Hence, these saturated hydrocarbons are inert. However, in sunlight, chlorine gets added to hydrocarbons. Since chlorine replaces the hydrogen atoms one by one, it is called a substitution. Ethanol and ethanoic acid. Ethanol. Ethanol is commonly known as alcohol and is liquid at room temperature. It is an active ingredient of all alcoholic drinks. It is a good solvent and hence is used in medicines. Consuming small quantities of dilute ethanol leads to drunkenness, but intake of a small quantity of pure ethanol can lead to death. Ethanoic acid. Ethanoic acid is commonly known as acetic acid. It is a part of the carboxylic acids group. When 5 to 8% solution of acetic acid is mixed in water, it forms a substance called vinegar. The melting point of pure ethanoic acid is 290 Kelvin. Because of this property, it freezes during winter and hence is also known as glacial acetic acid. Carboxylic acids are characterized by special acidity. However, as carboxylic acids are not ionized, they are weak acids. Soaps and detergents. Soaps and detergents are used in our daily life to wash clothes, clean hands, clean utensils, etc. The substances that form soap are sodium or potassium salts with long chains of carboxylic acids. The soap molecules form a separate structure called micelles. A micelle is formed when a variety of molecules, including soaps and detergents, are added to water. These molecules must have a strong polar head and a nonpolar hydrocarbon chain tail. When you add this molecule to water, the nonpolar tails of the molecules clump into the center of a ball. This is because they are hydrophobic or water-hating. The polar head of the molecule interacts with the water molecules on the outside of the micelle. Did you know? Artificially manufactured hydrocarbons are called trans. Our body lacks the enzymes to properly break down the trans compounds. That is why trans fats are dangerous and unhealthy, as they tend to build up. Carbon is the fourth most abundant chemical element in the universe by mass after hydrogen, helium, and oxygen. Carbon is abundant in the sun, stars, comets, and in the atmospheres of most planets. Summary. Let us summarize what we have learned. Carbon is a non-metallic substance with 4 electrons and helps in forming covalent bonds. The versatile nature of carbon can be summarized with tetravalency, strong carbon-carbon covalent bonds, and carbon-carbon multiple bonds. The chains of carbon atoms are linear chains, branched chains, and cyclic rings. Carbon is a friendly element that bonds with other elements. Homologous series is a series of related chemical compounds that have the same functional group. The system of assigning a proper name to a particular carbon compound is called nomenclature. The chemical properties of carbon are combustion, oxidation, addition reaction, and substitution reaction. Introduction. Let's play a game. There is a prize for the student who first searches where I have hidden the box of chocolates. Sir, but how do we search for it? Are you giving us any hints? No, Sagar. There will be no hints. You have to find out on your own. Do you think it will be easy? The entire class will keep searching for it, and this would lead to chaos. Sir, I don't think so. Sagar, you are correct. Similarly, when elements were discovered, there was a chaos. Let me tell you about this in detail. Children, in this lesson we will learn about the basis on which elements are classified. Objectives. At the end of this lesson you'll be able to describe the early attempts at classifying elements, explain Mendeleev's periodic table, explain the modern periodic table. Early attempts at classification of elements. In the early days, scientists classified elements purely on the basis of whether they were metals or non-metals. This had its own limitations. All elements were grouped in only 2 categories. This made the metals category very big. Some elements had the properties of both metals and non-metals. They could not be placed in any of the classes. This increased the need to identify some kind of pattern or regularity in the properties of the elements and then classify them. Dobereiner's triads. In 1829, Dobereiner, a German scientist, made groups of 3 elements, each based on their properties. He named them triads. He observed that atomic mass of the middle element of a triad was equal to the arithmetic mean of atomic masses of other 2 elements. For example, in a triad of calcium, Ca40, strontium, Sr88, and barium, Ba137, the mean of the atomic masses of the first and third elements is equal to the atomic mass of the second element. That is 40 plus 137 whole upon 2, which is 88 mu. Did you know? The German writer Goethe was a friend of Dobereiner. He attended his lectures weekly and used his theories of chemical affinities as a basis for his famous 1809 novella, Elective Affinities. Newland's Law of Octaves. Dobereiner's research simultaneously encouraged other scientists to start classifying elements. The triads were not useful as they could classify only 3 elements at a time. In 1864, John Alexander Newland, an English chemist, discovered that when elements are arranged in the increasing order of their atomic masses, atomic weight, every 8th element had properties similar to the first element. This is called the law of octaves. However, all elements could be arranged in this order only till calcium, even though there were more than 60 elements available at that time. Did you know? Like other scientists, Newlands used the terms equivalent weight and atomic weight without differentiating the words with their meaning, and in his first paper in 1863, he used the values accepted by his predecessors. This term is now referred to as relative atomic mass. Mendeleev's periodic table. Dmitry Mendeleev, a Russian chemist, discovered that elements, after arranging them in the increasing order of atomic mass with similar chemical properties, occurred periodically. In 1869, he stated this observation in Mendeleev's periodic law. He also discovered that a periodic function repeats itself after a certain interval. Hence, according to the periodic law, the chemical and physical properties of elements repeat themselves after certain intervals when they are arranged in the increasing order of their atomic mass. A tabular arrangement of the elements based on the periodic law is called periodic table. Mendeleev arranged all elements in their increasing order in horizontal rows till he encountered an element that had properties similar to the first element. He placed this element below the first element and thus started the second row of elements. This helped him to arrange all the known elements according to their properties. He was thus able to create the first periodic table. Features of Mendeleev's periodic table. Mendeleev's periodic table has the following features. The horizontal rows represented in the periodic table are called periods. There are 7 periods in the periodic table, numbered from 1 to 7. Properties of elements in a particular period show regular gradation from left to right. The vertical columns are called groups. These groups are 9 in number and are numbered from 1 to 8 and 0. Groups 1 to 7 are further divided into A and B subgroups. Groups 0 and 8 do not have any subgroups. All the elements in a particular group are chemically similar. They show regular gradation in their physical properties and chemical reactivities. Defects of Mendeleev's periodic table. Mendeleev's periodic table had certain defects. They are listed below. Hydrogen could neither be placed with alkali metals nor with halogens, as hydrogen resembles alkali metals as well as halogens. Different isotopes of same elements have different atomic masses. This need to be taken into consideration, and each one of them should be given a different position in the periodic table. However, because they are chemically similar, they had to be given same position. At certain places, an element of higher atomic mass has been placed before an element of lower atomic mass. For example, argon 39.91 is placed before potassium 39.1. Did you know? Mendeleev studied petroleum origin and concluded that hydrocarbons are abiogenic and come from deep within the earth. He wrote, "The capital fact to note is that petroleum was born in the depths of the earth, and it is only there that we must seek its origin." The modern periodic table. Henry Moseley, an English physicist, in 1913, discovered that the atomic number is the most fundamental property of an element. Atomic number of an element refers to the number of protons in the nucleus of its atom. The number of electrons in the neutral atom is also equal to its atomic number. This led to a change in the periodic law. The modern periodic law states that the chemical and physical properties of elements are a periodic function of their atomic numbers. Position of elements in the modern periodic table. The most commonly used periodic table is the long form of modern periodic table. Let us look at some features of the periodic table. Groups. The periodic table has 18 columns. These columns are called groups. The extreme left elements of the group contain alkali elements, and the extreme right elements contain noble gases,
All elements in the group have similar electronic configurations and have the same number of valence electrons. Periods. The 7 rows in the periodic table are called periods. In each period, a new shell fills up. The period number is also the number of shell which starts filling up. Trends in the modern periodic table. Valency. The valency is calculated by the number of valence electrons present in the outermost shell of its atom. The number of valence electrons increases in a period. Atomic size. Physical properties like density, melting, and boiling points relate to the sizes of atoms. The atomic size is very difficult to define. However, the atomic radius helps in determining the size of an atom. Metallic and non-metallic properties. The characteristics of metals are its electropositive character, which means the tendency to lose electrons, metallic luster, ductility, malleability, and electrical conductance. The metallic character of an element depends upon the ionization energy it generates. The smaller the value of ionization energy, more electropositive and more metallic the element would be. Summary. Let us summarize what we have learned. Scientists classified elements based on metals and non-metals. Dobereiner identified elements with similar properties and arranged them into groups called triads. Newlands arranged the elements in the order of increasing atomic masses. This is the law of octaves. Mendeleev created the periodic table and classified elements based on elements were arranged on the basis of the atomic mass. Moseley created the modern periodic table where the elements were further classified based on the atomic number of an element.
Introduction. We know that all the organisms perform some basic functions to keep themselves alive. Do you know what are life processes? Yes, the basic functions performed by living organisms to maintain their life on this earth are called life processes. Since living organisms perform various functions to maintain their life, to perform these functions, energy is required. They get this energy from outside the body in form of food.
Objectives. At the end of this lesson, you'll be able to define life processes, identify types of life processes, understand the nutrition, understand autotrophic nutrition, understand heterotrophic nutrition, find the types of heterotrophic nutrition, understand types of heterotrophic nutrition, understand nutrition in plants, understand process of photosynthesis, find out how do plants obtain carbon dioxide and water, and understand significance of photosynthesis. Types of life processes. There are following basic life processes: movement, respiration, sensitivity, growth, reproduction, excretion, nutrition, transportation. During movement, organism either moves from one place to other or move its body parts while staying fixed at one place. While respiration is the process which releases energy from food absorbed by the body. Sensitivity is the ability to detect the changes in the surroundings. We can define growth as change from child to adult. Organisms produce new organisms similar to it by the process of reproduction. Excretion is the process in which waste materials are removed from the body. The process of nutrition involves the taking of food inside the body and converting it into smaller molecules which can be absorbed by the body. Transportation is the process in which a substance absorbed or made in one part of body are moved to another parts of the body. Nutrition. As we have discussed earlier that all living organisms perform various functions to maintain their life. To perform these functions, energy is required.
They get this energy from outside the body in form of food. The process of taking in food and utilizing it is called nutrition. Food is an organic substance. The simplest food is glucose, while complex food is starch. Starch and glucose in combined form are known as carbohydrates. When we require instant energy, then we should take carbohydrates. In addition to carbohydrates, food should also contain fats, protein, mineral salts, vitamins and water because they all are essential for normal growth and development of an organism. Modes of nutrition. Procuring food by an organism is known as mode of nutrition. The general requirement for energy and materials is common to all, but it is fulfilled in different ways. So every organism has different mode of nutrition. Broadly, organisms are divided into two groups according to method of obtaining food: autotrophic, heterotrophic. Autotrophic nutrition. Auto means self and trophic means nutrition. So it literally means self-nutrition. Autotrophic mode of nutrition is that mode of nutrition in which an organism makes its own food from the simple inorganic materials like carbon dioxide and water present in the surroundings. The green plants have an autotrophic mode of nutrition. The autotrophic cyanobacteria also obtain their food by the autotrophic mode of nutrition. So we can say that those organisms which can make their own food from carbon dioxide and water are called autotrophs. The autotrophic organisms contain the green pigment called chlorophyll, which is capable of trapping sunlight, solar energy. The trapped solar energy is utilized by the autotrophs to make food by combining CO2 and water by the process of photosynthesis, and as a result, glucose is formed. Here is the reaction of photosynthesis. Heterotrophic nutrition. Hetero, other, trophic, nutrition. So it literally means nutrition obtained from others. A heterotrophic mode of nutrition is that mode of nutrition in which organism cannot make its own food from the simple inorganic materials like carbon dioxide and water and depends upon other organisms for its food. Most bacteria, fungi, and all the animals have a heterotrophic mode of nutrition. Those organisms which cannot make their own food from inorganic substances like carbon dioxide and water and depend on other organisms for their food are called heterotrophs. A heterotroph is a consumer which gets its nutrition from other organisms. That is, heterotrophs depend on autotrophs and other heterotrophs for their food. Types of heterotrophic nutrition. Heterotrophs get their food in three ways: saprophytic, parasitic, holozoic. Sapro means rotten and phytic means nutrition. Saprophytic nutrition is that in which an organism obtains food from decaying organic matter of dead plants, dead animals, and rotten bread. That is, fungi and many bacteria are saprophytes. Para, which means besides, cytos means grain food. Parasitic is an organism that grows, feeds, and is sheltered on or in a different organism while contributing nothing to the survival of its host. That is, Plasmodium, Cuscuta, tapeworm, etc. Holo, feeding on solids, and zoic, zoon, means animals. Holozoic nutrition is ingesting and using complex organic material as food as most animals do. That is man, dog, cattle, amoeba. Nutrition in plants. As we have already discussed that green plants are autotrophic and synthesize their own food by the process of photosynthesis. Photosynthesis. Photo means light and synthesis means to build. Thus, photosynthesis means building up food with help of light. Photosynthesis is the process used by all green plants, blue-green algae, cyanophyta, and certain bacteria. It is the synthesis of organic compounds, primarily sugars from carbon dioxide and water, using sunlight as the source of energy, and chlorophyll for trapping the light energy. Photosynthesis can be summarized by this equation. The photosynthetic process has been shown to be divided into two major phases. Light stage, light-dependent reactions, represents conversion of radiant energy to chemical energy in the form of ATP. Dark stage, light-independent reactions, represents the enzymatic synthesis of carbohydrate immediates and other compounds by the utilization of the ATP produced during the light stage. The process of photosynthesis takes place in the following three steps: absorption of sunlight energy by chlorophyll, conversion of sunlight energy into chemical energy, splitting of water into hydrogen and oxygen by light energy, reduction of CO2 by hydrogen to form carbohydrate like glucose by utilizing the chemical energy, intake of carbon dioxide. Carbon dioxide is present in the atmosphere. Green plants take CO2 from air with the help of tiny pores present on the surface of leaves. These tiny pores are known as stomata. Carbon dioxide enters the leaves of the plants through the stomata. Each stomatal pore is surrounded by a pair of guard cells. The opening and closing of stomatal pores is controlled by these guard cells. When water flows in the guard cells, they swell, become curved, and cause the pore to open. On the other hand, when guard cells lose water, they shrink, become straight, and close the stomatal pore. As the pore opens, atmospheric carbon dioxide enters the pore. Intake of water. The water required by the plants for photosynthesis is absorbed by the roots of the plants from the soil through the process of osmosis. The water absorbed by the roots of the plants is transported upwards through xylem vessels to the leaves, whereas it reaches the photosynthetic cells and is utilized in photosynthesis. Significance of photosynthesis. Photosynthesis is important for a number of reasons. Few of them are main. By photosynthesis, green plants synthesize food from single raw materials like CO2 and H2O. Thus, it sustains life on Earth. Oxygen is released during the process of photosynthesis, is needed by animals and human beings. It is also required for respiration of microbes. Oxygen also supports combustion of fuels. Fossil fuels like coal, oil, and natural gas are forms of stored solar energy synthesized by photosynthesis millions of years ago.
Assessment. Before proceeding further, let us know how much you have learned. Drag and drop the correct option.
Did you know? ATP is energy currency. Leaves are green because they fail to absorb green light of visible spectrum which is reflected. Blue and red light are best for photosynthesis. Light-dependent reactions take place in thylakoids of chloroplasts. The site of carbon dioxide fixation is grana of chloroplasts. Light is emitted in packets of energy known as photons. The splitting of water is known as photolysis. Summary. Let us summarize what we have learned. Living organisms require oxygen, water, and food in every cell of their various tissues to sustain life. The various processes essential for maintenance of life are called life processes. The main life processes are movement, respiration, sensitivity, growth, reproduction, excretion, nutrition, and transportation. Energy is continuously required by living organisms to carry out various life processes. This energy is liberated due to intake as well as utilization of nutrients and also by respiration of an organism. Organisms can be divided into two types on the basis of mode of nutrition: autotrophic and heterotrophic. Autotrophic nutrition involves the intake of simple inorganic materials from the environment and using an external energy source like the sun to synthesize complex, high-energy organic material. Heterotrophic nutrition involves the intake of complex material prepared by other organisms.
Introduction. We know that animals are heterotrophic and hence they depend on other organisms for their food. Yes, animals need an external source of food. So we can also say that they depend upon ready-made food, and this may come either from plants or from other animals. There is a wide variety of animals on the basis of their type of food. Yes, Ankita, many animals eat only plants like grasses, leaves of plants, while some of them eat other animals. The big fish eat small fish, the birds eat worms and insects, snakes eat frogs, some insects eat dead bodies of animals. But when we observe it closely, we find that all the living things on earth actually depend on the sun for their food, directly or indirectly. Plants use the energy of the sun and prepare food by photosynthesis, which is utilized by them to maintain their life. In turn, these plants are also eaten up by herbivores and omnivores as food. And the carnivores eat herbivores as their food. In this way, we see that it is energy from the sun which provides food for plants and animals.
Objectives. At the end of this lesson, you'll be able to understand nutrition in animals, find out types of animals on the basis of food habits, understand Holozoic nutrition, find out various steps of Holozoic nutrition, understand nutrition in human beings, find out various organs of digestive system, understand structure and functions of mouth, buccal cavity, pharynx, esophagus, stomach, small intestine, large intestine, and anus. Find out various digestive glands, understand structure and functions of salivary and gastric glands, understand structure and functions of liver, understand structure and functions of pancreas and intestinal glands, study chemistry of digestive glands. Types of animals. All the animals can be divided into three groups on the basis of their food habits: herbivorous, carnivorous, omnivorous. As we have already discussed that the animals which eat only plants are called herbivorous. They may eat grasses, leaves, grains, fruits, or the bark of trees. Examples: goat, cow, buffalo, sheep, deer, camel, ass, ox, elephant, monkey, squirrel, rabbit, grasshopper, and hippopotamus. Similarly, those animals which eat only other animals as food are called carnivorous. Examples: lion, tiger, frog, vulture, kingfisher, lizard, wolf, snake, and hawk. Other than that, those animals which eat both plants and animals are known as omnivorous. Examples: man, dog, crow, sparrow, bear, myna, and ant. Holozoic nutrition. Holozoic nutrition, holo means whole and zoikos means animals, is a method of nutrition that involves the ingestion of liquid or solid organic material. The process of holozoic nutrition involves 5 steps: ingestion, digestion, absorption, assimilation, and egestion. Ingestion involves intaking of food. It depends on the size of food and structure adopted for ingestion. Ingestion occurs with the help of pseudopodia in amoeba, cilia in paramecium, tentacles in hydra, mouthparts in insects, protrusible tongue in frogs and wall lizards, hands in human. Digestion is the process by which complex, large-size, insoluble and non-diffusible polymeric organic compounds are changed into simple, small, soluble and diffusible monomeric compounds. Organic compounds like proteins, fats, and complex carbohydrate, amino acids, monosugars, fatty acids, etc. It occurs in the presence of digestive enzymes present in digestive juices secreted by the digestive glands. Absorption is the process by which diffusible nutrients pass through the wall of alimentary canal into blood lymph. Absorption involves both physical processes like diffusion and osmosis and active processes like active transport of glucose, amino acids, etc. Assimilation is an anabolic process by which simple nutrients are metabolized to resynthesize the complex macrobiomolecules like proteins, polysaccharides, fats, etc. It occurs inside the cells. The synthesized macrobiomolecules help in growth and repair of the body tissues. Egestion is the process in which undigested food is removed from the body. The whole food which we eat is not digested by our body. A part of the food which we eat remains undigested, which cannot be used by the body. This undigested part of the food is then removed by the body in the form of feces when we go to the toilet. Nutrition in human beings. In human beings, nutrition takes place through human digestive system. The various organs of the human digestive system are mouth, buccal cavity, pharynx, esophagus, stomach, small intestine, large intestine, rectum, anus. Mouth. Mouth is a transverse aperture bounded by movable lips. Its main function is ingestion. Buccal cavity. Buccal cavity has 2 main structures in it: tongue, teeth. Tongue is a thick, muscular and protrusible structure present on floor of buccal cavity. Tongue has taste buds or papillae which help in tasting food, mixes food and saliva and facilitates swallowing. Teeth are present in both jaws of human beings. Teeth are embedded in the sockets of jaw bones. In adult man, there are 32 teeth, 16 in each jaw. Teeth are of 4 types: incisors, canine, premolars, molars. Incisors are 4 in each jaw. They are sharp and chisel-shaped and are for biting and cutting of vegetable food. Canine are 2 in each jaw. They are sharp and dagger-shaped and are for tearing animal food. Premolars are 4 in each jaw. They are broad and cusp-shaped and are for chewing and grinding. Molars are 6 in each jaw. They are broad and cusp-shaped and are for chewing and grinding. Pharynx. Pharynx is a funnel-shaped part where the food and air passage cross each other. It has 2 apertures. Glottis leads into voice box and windpipe. Gullet leads into esophagus and opens during swallowing of food. Esophagus. Esophagus is long, narrow and tubular part of digestive system. It passes through neck and pharynx and opens in stomach. It conducts the food by peristalsis. Stomach. Stomach is a thick, muscular and J-shaped sac present on the left side of upper abdomen. Stomach helps in mechanical churning and chemical digestion of food. The food is churned in stomach for about 3 hours, due to which the food breaks down into smaller pieces and forms a semi-solid paste. The stomach wall contains 3 tubular glands in its walls which secrete gastric juices. The gastric juices contain 3 substances, HCl, enzyme pepsin, and mucus. Due to presence of HCl, enzyme pepsin is acidic in nature and starts digestion of proteins. The mucus helps to protect the stomach wall from its own secretion of HCl acid. The muscular wall of stomach helps in mixing of food and gastric juices. Small intestine. Small intestine is the largest part of alimentary canal. It is about 6.5 meters long in an adult man. It is called small intestine because it is very narrow. Small intestine is divided into duodenum, jejunum, ileum. Small intestine is site of complete digestion of food and also the absorption of food. Large intestine. Large intestine is shorter and wider than small intestine. It is divided into colon and rectum. It helps in formation and temporary storage of feces. The colon is the last part of the digestive system in most vertebrates. It extracts water and salt from solid wastes before they are eliminated from the body. Rectum is the last 6 to 8 inches of the large intestine. The rectum stores solid waste until it leaves the body through the anus. Anus. Anus lies at the base of trunk and is for egestion of waste products of digestive system. The digestive glands. In addition to these organs, there are some digestive glands which secrete digestive enzymes. These are salivary glands, gastric glands, liver, pancreas, intestinal glands. Salivary glands. There are 3 pairs of salivary glands in human. These secrete saliva, which contains a digestive enzyme ptyalin or salivary amylase. Salivary ducts open in buccal cavity. Gastric glands. Gastric glands are present in the wall of stomach and secrete gastric juices. Liver. Liver is lobulated and reddish-brown colored largest gland of body present in the right side of upper part of abdomen which secretes bile juice. Pancreas. Pancreas is yellow gland present just behind the stomach which secretes pancreatic juice. Pancreatic duct carries pancreatic juice to small intestine. Intestinal glands. Intestinal glands lie in the wall of small intestine and secrete intestinal juice, which is also known as succus entericus. Enzymes working in digestive system of man. Saliva has salivary amylase, which digests starch into sugar. Pepsin in presence of HCl digests protein, which works only in acidic medium. Bile from liver, gallbladder, digests fat and converts it into fatty acids. It changes food to alkaline medium. Amylase digests starch from pancreas. Trypsin digests proteins from pancreas. Lipase breaks down emulsified fats from pancreas. Dental caries. Dental caries or tooth decay causes gradual softening of enamel and dentine. Dental caries starts when bacteria acting on sugars produce acids that softens and demineralizes the enamel. Masses of bacterial cells together with food particles stick to the teeth to form dental plaque. Saliva cannot reach the tooth surface to neutralize the acid as plaque covers the teeth. Proper brushing the teeth after eating removes the plaque before the bacteria produce acids. If untreated, microorganisms may invade the pulp, causing inflammation and infection. Did you know? In man, vermiform appendix is a vestigial tube at the junction of small intestine and large intestine. Elongation and inflammation of vermiform appendix is called appendicitis. Period of gastric digestion depends upon nature of food. It is 1 to 2 hours for carbohydrates and 5 to 6 hours for fats. Summary. Let us summarize what we have learned. Heterotrophs cannot make their own food and depend on other organisms for their requirement of food. Nutrition involves utilization of food and involves a number of steps like ingestion, digestion, absorption, assimilation, and egestion. Amoeba is omnivorous and holozoic. In amoeba, food is ingested by circumvallation with the help of pseudopodia. In amoeba, digestion is intracellular and occurs in the food vacuole. Alimentary canal of human being is formed of mouth, buccal cavity, pharynx, esophagus, small intestine, large intestine, and anus. Teeth in man are heterodont. Food moves down the gut by the process of peristalsis. Digestive glands of man include 3 pairs of salivary glands, gastric glands, liver, pancreas, and intestinal glands. Digestive glands secrete digestive juices which contain digestive enzymes. Digestion of carbohydrates starts in buccal cavity, while that of proteins and fats is started in stomach. Digestion is completed in small intestine. Absorption of food also takes place in small intestine. Dental caries is caused by Streptococcus mutans bacteria, which causes fermentation of sugary diet and produces organic acids.
Introduction. As we have discussed earlier, that every living organism take in the food material by the process of nutrition provides energy for various life processes. Respiration is an oxidative process involving the oxidation of food substances such as carbohydrates, fats, and proteins within the tissues to form CO2, water, and consequent release of energy. The released energy is temporarily stored as ATP. There is big difference between breathing and respiration. I know that breathing is simply exchange of gases. Yes, Ankita, during breathing, an organism takes in oxygen from the environment and gives out carbon dioxide, while respiration is a complex process during which digested food is oxidized to release chemical energy.
Objectives. At the end of this lesson, you'll be able to find out types of respiration on the basis of use of oxygen, understand anaerobic and aerobic respiration, find out the whole process of respiration in lower and higher animals, understand human respiratory system, understand structure and functions of nostrils, nasal cavity, larynx, trachea, bronchi, bronchiole, alveoli, lungs, diaphragm. Find out pulmonary volumes and capacities. Understand transport of gases in blood. Study respiratory quotient, RQ. Understand ill effects of smoking. Types of respiration. Respiration is of two types: anaerobic respiration and aerobic respiration. Anaerobic respiration is the respiration without oxygen, while aerobic respiration is respiration that requires oxygen. Do you know that in higher animals, whole process of respiration includes external respiration, internal respiration, and cellular respiration? Anaerobic respiration. When food is oxidized without using molecular oxygen, the respiration is called anaerobic respiration. Some common examples are anaerobic bacteria, yeast, parasitic worms like Ascaris, Taenia, Fasciola, etc. In microorganisms, the term fermentation is more commonly used in place of anaerobic respiration. Fermentation is defined as the anaerobic breakdown of carbohydrates and other organic compounds into alcohols, organic acids, gases, etc. with the help of microorganisms or their enzymes. Aerobic respiration. When oxygen is used for respiration, it is called aerobic respiration. Examples: most plants and animals. Do you know when there is a lack of oxygen in our muscle cells? Then pyruvate is converted into lactic acid, which is also a 3-carbon molecule. If we perform any sudden activity, then cramps are caused in our muscles due to the formation of lactic acid. External respiration. External respiration is the process by which gases are exchanged between the blood and the air. It is a physical process. It is simply the intake of oxygen and giving out of carbon dioxide. It involves two phases: inspiration and expiration. Inspiration is a process by which fresh air enters in the lungs. In this, diaphragm becomes flat and gets lowered by the contraction of its muscle fibers and increases the volume of the thoracic cavity. The external intercostal muscles contract and pull the ribs and sternum upwards and outwards direction, and thus the volume of thoracic cavity is increased. Expiration is a process by which CO2 is expelled out from the lungs. Muscles fibers of the diaphragm relax, make it convex, decreasing the volume of the thoracic cavity. External intercostal muscles relax and pull the ribs downwards and inwards direction, thus decreasing the size of the thoracic cavity. Internal respiration. Internal respiration is the process by which gases are exchanged between blood and tissue fluid and between tissue fluid and cells. Cellular respiration. Cellular respiration is the process by which cells use oxygen for metabolism and give off CO2 as a waste. Exchange of gases in lower animals. In lower organisms, there is no special organ for respiration. So, cell in unicellular and every cell in multicellular organisms of the body take part in respiration. Every cell is in direct contact with water. Therefore, there is direct exchange of oxygen of surrounding water and carbon dioxide of body cells. This is known as body surface respiration. Oxygen inside the mitochondria of cells is used in the oxidation of glucose to produce CO2, water, and energy-rich molecules. Some common examples are amoeba, paramecium, sponges, and coelentrates. Exchange of gases in higher animals. In higher organisms, the body wall is thick. As a result, diffusion is not possible, and they have high metabolic rate, so they require high energy. As required, higher animals have special respiratory organs for exchange of gases. They also have blood vascular system to transport oxygen and CO2 between the respiratory organ and the body cells. Exchange of gases in higher animals may be through skin, gills, trachea, or lungs. Skin respiration is found in annelids and amphibians. Exchange of gases occurs through skin which is thin, moist vascular, and permeable. It is also called cutaneous respiration. Gill respiration is found in crustaceans, cartilage fishes, bony fishes, and tadpoles of amphibians. It is also called branchial respiration. Oxygen is received from water. Exchange of oxygen of water and CO2 of blood capillaries present in gill lamellae occur when water passes through the gills. Tracheal respiration is found in all insects. Respiratory organs are highly branched air tubes known as trachea. These tracheas are connected to air by small openings called spiracles. Lung respiration is found in land animals and man. Respiratory organs are lungs. It is also known as pulmonary respiration. It occurs with the help of respiratory system. Human respiratory system. Structurally and functionally, the conducting part of human respiratory system is highly complicated. The mammalian respiratory system consists of nostrils, nasal cavity, larynx, trachea, bronchi, bronchiole, alveoli, lungs, diaphragm. Nostrils. Holes of the nose are called nostrils. These are paired openings that open up into the nasal chambers. Nasal cavity. It is divided into two nasal chambers by the nasal septum. Each nasal chamber consists of three regions, that is, vestibular, respiratory, and olfactory regions. Larynx. Larynx contains vocal cords, the sound-producing elastic fibers called voice box. There is a little difference in the size of the larynx in man and woman. It grows larger and becomes prominent in man, and therefore it is called Adam's apple in man. Human larynx consists of glottis, cartilages, hyoid bone, thyroid membrane, vocal cords, laryngeal ligaments, and muscles. Glottis is an opening in the floor of pharynx leading to larynx. There are 9 pieces of cartilages. 3 are single and 3 are paired. Epiglottis is a leaf-like structure that prevents the entry of food into respiratory tract during swallowing. Trachea. The trachea or windpipe is a continuation of the larynx. Trachea is supported by incomplete C-shaped rings of hyaline cartilages. The mucosa of trachea is lined with a ciliated pseudostratified epithelium containing mucus-secreting goblet cells, which helps in pushing mucus out. Bronchi. A bronchus, plural bronchi, adjective bronchial, is a passage of airway in the respiratory tract that conducts air into the lungs. Bronchiole. The bronchus branches into smaller tubes, which in turn become bronchioles. No gas exchange takes place in this part of the lungs. Alveoli. The alveoli are the ultimate structural and physiological units of lungs. Alveoli provide great surface area, like villi of intestine in mammals, for gaseous exchange by diffusion. Gaseous exchange occurs across the respiratory membrane of the alveoli, lungs. Each lung is covered by double membrane called pleurae. The outer covering membrane of lung is called parietal pleura. The inner covering membrane of lung is called visceral pleura. In human, the right lung has the 3 lobes and left lung has 2 lobes. Diaphragm. The diaphragm is a dome-shaped muscular structure separating the thoracic and abdominal cavities. The diaphragm is characteristic of mammals. The diaphragm is supplied by the phrenic nerves. Puncturing of diaphragm results in stoppage of breathing and is fatal. Respiratory and pulmonary volumes and capacities. There are 4 respiratory volumes: tidal volume, TV, inspiratory reserve volume, IRV, expiratory reserve volume, ERV, residual volume, RV, and 4 respiratory capacities: inspiratory capacity, IC, functional residual capacity, FRC, vital capacity, VC, and total lung capacity, TLC. The recording of breathing is known as spirogram. The quantities of air that lungs can receive, hold, and expel under different conditions are called pulmonary volumes, and combination of 2 or more pulmonary volumes are called pulmonary capacities. The apparatus commonly used to measure the pulmonary volume is a spirometer or respirometer. Transport of gases in blood. Oxygen transport. 98.5% of oxygen is transported by blood with the help of the respiratory pigment hemoglobin present in erythrocytes, RBCs. 1 molecule of hemoglobin can carry as much as 4 oxygen molecules. 1 gram of hemoglobin binds about 1.34 ml of oxygen. Thus, 100 ml of pure blood carries about 20 ml of oxygen. Carbon dioxide transport. Transport of carbon dioxide by blood is much easier than that of oxygen due to high solubility of CO2 in water. About 7% of CO2 is transported as dissolved in plasma, 23% as carbaminohemoglobin, and 70% as bicarbonates. Most of the CO2 is transported by blood in the form of sodium bicarbonate in plasma. Respiratory quotient, RQ. Respiratory quotient is the ratio of volume of CO2 released to volume of O2 absorbed. RQ varies for substrate to substrate. Therefore, determination of RQ can give valuable information about the nature of the substrate being used for respiration and the types of metabolism. Ill effects of smoking. Tobacco smoke has a number of toxic chemicals which cause ill effects on human health. It is responsible for lung cancer, coughing, bronchitis, emphysema, and carbon monoxide poisoning. Did you know ATP is the energy currency for most cellular processes? The energy released during the process of respiration is used to make an ATP molecule from ADP and inorganic phosphate. Endothermic processes in the cell then use this ATP to drive the reactions. When the terminal phosphate linkage in ATP is broken using water, the energy equivalent to 30.5 kJ per mole is released. ATP can be used in the cells for the contraction of muscles, protein synthesis, conduction of nervous impulses, and many other activities. If the alveolar surface was spread out, it would cover about 80 meters square. If diffusion were to move oxygen in our body, it is estimated that it would take 3 years for a molecule of oxygen to get to our toes from our lungs. Summary. Let us summarize what we have learned. Breathing involves 2 processes: inspiration and expiration. Rib muscles and diaphragm help in breathing. Aerobic respiration takes place with the help of oxygen and is responsible for complete breakdown of hexose into carbon dioxide and water. Anaerobic respiration is incomplete breakdown of substrate in the absence of oxygen. Lower organisms show body surface respiration, while higher organisms have special respiratory organs like skin in annelids, trachea in insects, skin and lungs in amphibians, gills in crustaceans and fishes, and lungs in reptiles, birds, and mammals. Respiratory system of man is formed of nostrils, nasal chamber, glottis, trachea, bronchi, and bronchial intercom inside the human lungs. Tobacco smoke has a number of toxic chemicals which cause ill effects on human health. It is responsible for lung cancer, coughing, bronchitis, emphysema, and carbon monoxide poisoning.
Introduction. We all know that all plants need water. The wilted leaves recover when plant is added to the soil, which means that water has been conducted upwards into the leaves. Yes, we have also learnt that the leaves for photosynthesis need water. Likewise, the food produced in the leaves has to be transported to other parts of the plant, including the stem, the roots, flowers and fruits, etc. All this transportation is the function of conducting tissues. Yes, Ankita, similarly, in animals, the food absorbed by the gut has to be carried to all the body parts. Oxygen absorbed in the lungs has to be transported to every cell of the body. The carbon dioxide produced in the cells has to be carried to the lungs for elimination. All such functions are the result of a transport system.
Objectives. At the end of this lesson, you'll be able to understand the need for a system of transport in plants and animals, find out mechanism for movement of molecules such as diffusion, understand osmosis and active transport, understand the importance of blood as a medium of transport, find out the structure and function of human heart, understand the composition of blood, understand difference between arteries, veins and capillaries, understand the major blood groups and state the matching groups for blood transfusion, find out disorders of circulatory system, and find out the structure and function of xylem and phloem in plants. Mechanisms for movement of molecules. Molecules move in and out of a cell through the cell membrane. The cell membrane is selectively permeable to substances, which means that it permits entry and exit of certain molecules only. The movement of molecules takes place by diffusion, osmosis, and active transport. Diffusion is movement of particles or molecules from a region of their higher concentration to a region of their lower concentration. For example, during respiration, oxygen-laden air in lungs, being at a higher concentration, moves into blood capillaries having lower concentration of oxygen in them. Osmosis is the movement of water molecules from a region having more water molecules to a region having less water molecules when separated by a semi-permeable membrane. Semi-permeable membrane means a membrane which allows some molecules, that is, water molecules, to pass through it, but not some other larger molecules. No energy is spent during diffusion or osmosis. Active transport is movement of molecules against concentration gradient, that is, from a region of their lower concentration to a region of their higher concentration. Energy is required in active transport. Transport of materials in human beings. In the body of majority of animals, substances are transported from one part of the body to another through blood. Thus, blood is the tissue of transport and circulates throughout the body. Blood transports nutrients, respiratory gases, hormones, and waste material from one part of the body to another. Circulatory system consists of organs which make blood circulate throughout the body. Human circulatory system consists of centrally located muscular pump called heart and blood vessels, which are tube-like structures connected to the heart. Blood vessels are of three kinds: arteries, veins, and capillaries. Arteries. They carry blood from heart to various parts of the body. Veins. They bring blood from various parts of the body to the heart. Capillaries. These are thin vessels between the artery and the vein. The capillaries allow the exchange of materials between blood and tissues. Human heart. Structure. Heart is a powerful muscular organ lying between lungs in the upper part of thorax of our body. It is four-chambered, two right and left atria, singular, atrium, also called auricles, and two right and left ventricles. The heart is made of specialized muscle cells, also called cardiac muscle fibers, which contract and relax all the time without getting tired. The contraction and relaxation follows a rhythm called heartbeat to pump blood into the vessels. Rhythmic heartbeat results in the proper transport of substances to the various organs. In 1 minute, normal human heart beats about 72 times. Abnormalities in heartbeat can be seen by taking ECG or electrocardiography. Functions of human heart. Impure blood is the blood low in oxygen and high in carbon dioxide, and pure blood is full of oxygen. A large vein, the vena cava, collects impure or deoxygenated blood through veins from all parts of the body and empties into the right atrium. At the same time, vein from the lungs brings oxygen-laden blood to left atrium. At this time, all the four chambers of the heart are relaxed. Then the atria contract, and impure blood from right atrium enters the right ventricle, and purified blood from left atrium enters the left ventricle. Valves within the heart prevent blood from flowing back. Next, the ventricles contract while the atria relax. Blood to be purified is transported to the lungs from right ventricle through two pulmonary arteries. The oxygen-laden blood from the left ventricle gets pumped into a large artery called aorta. It carries oxygenated blood to all parts of the body. The veins bring impure blood to the heart, and the arteries take the pure blood away from the heart. But there are two exceptions. The pulmonary artery carries impure blood, and the pulmonary vein carries pure blood. Blood. Blood is a connective tissue that circulates throughout the body. It is made up of a fluid medium called plasma, in which float three types of blood cells called red blood cells, white blood cells, and blood platelets. Blood cells are manufactured in the bone marrow. Red blood cells, RBC, or erythrocytes. These are circular in shape and contain a red-colored pigment called hemoglobin. No nucleus is present in RBCs. RBC carries oxygen to tissues and bring back carbon dioxide from tissues. About 5 million mm³ erythrocytes occur in circulating blood. White blood cells, WBC, or leukocytes. Since they carry no pigments, therefore they so are colorless. WBC have irregular shape. In the circulating blood, 5,000 to 7,000 mm³ WCs are present. They prevent body from infections by eating up germs or by producing antibodies. Blood platelets, thrombocytes. These are very small fragments of cells. They have no nuclei. They participate in clotting of blood. Functions of blood. Blood carries nutrients, oxygen, carbon dioxide, hormones, and waste material to the relevant parts of the body. Some medicines, when taken in the body, are also distributed through blood. Lymph. Lymph is also a circulatory fluid and flows in the lymph vessels. It is light yellow in color. It always flows only in one direction from tissues to heart. Cells called lymphocytes present in lymph eat up germs and prevent body from infections. Lymph carries digested fats from intestine to other parts. It returns proteins and fluid from circulation to tissues. Blood pressure. The force that blood exerts against the wall of a vessel is called blood pressure. This pressure is much greater in arteries than in veins. The pressure of blood inside the artery during ventricular systole contraction is called systolic pressure, and pressure in artery during ventricular diastole relaxation is called diastolic pressure. The normal systolic pressure is about 120 mm of mercury and diastolic pressure is up to 80 mm of mercury. Blood pressure is measured with an instrument called sphygmomanometer. High blood pressure is called hypertension and is caused by the constriction of arterioles, which results in increased resistance to blood flow. It can lead to the rupture of an artery and internal bleeding. Disorders related to circulatory system. Heart attack. Like all other organs, heart also needs food and oxygen. When arteries supplying the heart become thick due to age or faulty diet consisting of excessive fatty food, muscle cells of the heart cannot beat in the proper rhythm. Heart attack occurs, which can be detected in an abnormal ECG, and there are methods of treatment. Anemia. When hemoglobin level falls below a certain point, the condition is called anemia. It makes the person weak and look pale and inactive. Iron in the diet helps remove anemia. Leukemia. This is blood cancer. The bone marrow makes excessive WBCs at the cost of RBCs. Hypertension. It is high blood pressure and leads to headache, dizziness and fatigue. Normal blood pressure is 120/80. High blood pressure is caused by anxiety also. Transport of materials in plants. Transport of water. Roots of plants take up water and minerals from the soil. We have already learnt this water move up from roots to leaves for needs like photosynthesis by conducting tissues, xylem and phloem. Tracheids and vessels, which are non-living cells of xylem, transport water picked up by root hairs from soil to the leaves. Transport of food material from leaves to other parts of the plant is called translocation. This food may be stored in fruits, stem or roots. Transport of water. The upward movement of water and minerals termed ascent of sap is against gravity and is due to transpiration pull. Transpiration is the process in which a lot of water evaporates as water vapor from pores on the surface of leaf called stomata. This evaporation creates a vacuum and pulls up water through the xylem. Transport of food and other substances. Transport of food material, sugars, and other food molecules synthesized in the leaves are transported to other parts of the plant through phloem. Sieve tubes are living cells of the phloem which transport food. Activity. Take two small pots of approximately the same size and having the same amount of soil. We will fix a plant in one pot and a stick of the same height as the plant in the other pot. Cover the soil in both pots with a plastic sheet so that moisture cannot escape by evaporation. Cover both sets, one with the plant and the other with the stick, with plastic sheets and place in bright sunlight for half an hour. The pot with plant has small droplets of water inside the plastic sheet. This is due to the transportation of water and transpiration from leaves. Did you know? Hemoglobin content is different in male and female human beings. Normal human male has 14.5 plus minus 2 gram%. Normal human female has 12 plus minus 2 gram%. In human beings, the blood passes through the heart twice in one complete cycle of the body. Therefore, it is called double circulation. The sinoarterial SA node is a small mass of specialized muscle cells found in the walls of the right atrium near the opening of the vena cava. This tissue initiates and maintains the heartbeat. When it fails to function, an electronic device pacemaker is implanted into the chest of the patient to maintain heartbeat. Summary. Let us summarize what we have learned. Molecules move in and out of cells by diffusion, osmosis, or active transport. In most animals, blood circulates through heart and blood vessels to reach all parts of body. Heart in humans is four-chambered. Two upper chambers are called atria and lower chambers are ventricles. Capillaries are thin blood vessels between an artery and a vein. Lymphatic system is made of lymph vessels in which a colorless fluid called lymph flows. In plants, water is absorbed from soil by root hairs and reaches leaves and other parts through xylem vessels.
Introduction. As we already know that how organisms get rid of gaseous wastes are removed by plants during photosynthesis and by animals during respiration. Yes, but liquid and solid wastes are still present in the body. So, we can say that the biological process involved in the removal of these harmful metabolic wastes from the body is called excretion. The process of excretion is different in different organisms. Yes, unicellular organisms remove these wastes by simple diffusion from the body surface into the surrounding water. Example, in amoeba, it is done through plasma membrane. While complex multicellular organisms use specialized organs to perform the same function. In Platyhelminthes, excretory organs are protonephridia or flame cells, while in annelids, it is nephridia. Yes, in arthropods, excretory organs are coxal glands, antennary or green glands, and Malpighian tubules, while in molluscus it is kidneys. Similarly, in echinoderms, excretory organs are dermal papillae, while in urochordates it is neural gland, and in cephalochordates it is protonephridia. In vertebrates, excretory organs are one pair of kidneys.
Objectives. At the end of this lesson, you'll be able to understand excretion in animals and plants, find out types of excretion, understand excretion in human beings, find out various organs involved in excretion, understand excretion by lungs, find out excretion by skin, understand excretion by large intestine, understand structure and functions of urinary system, find out structure and functions of kidneys, understand structure and functions of ureters, find out structure and functions of urinary bladder, understand structure and functions of nephrons, study about artificial kidney or hemodialysis, excretion in human beings. The primary excretory system of human beings includes a pair of kidneys, a pair of ureters, a urinary bladder, and a urethra. While secondary excretory system of human beings includes lungs, skin, large intestine, liver. Excretion by lungs. Lungs excrete carbon dioxide and water vapor formed during the process of respiration. Excretion by skin. Skin removes urea, salts, and excess water as sweat produced by sweat glands present in the skin. Sweat is removed through tiny pores in the skin. Excretion by large intestine. Large intestine removes the indigested food as feces through the anus. It is a storage area of waste material that awaits elimination. Urinary system. The organs that form, store, and excrete urine constitute the urinary system. It consists of a pair of kidneys, a pair of ureters, a urinary bladder, and a urethra. Urine produced in the kidneys passes through the ureters into the urinary bladder, where it is stored until it is released through the urethra. Kidneys. Kidneys are located in the abdomen, one on either side of the backbone. They are large-sized, reddish-brown, and bean-shaped. The right kidney is slightly lower in position. Concavity of kidney is called hilum, which is always inward. Each kidney is formed of about 1 million uriniferous or renal tubules or nephrons internally. Kidneys must function properly in order to keep a person in perfect health. Nephrons. Nephrons are convoluted in outer part of kidney called renal cortex, while run straight in central part of kidney called renal medulla. Nephrons are the functional units of kidneys. Each nephron is a long coiled tubular structure that filters out nitrogenous waste material from the blood and forms urine. Urea is the main nitrogenous waste present in urine, so man is ureotelic in excretion. Ureters. These are a pair of long, narrow, thin-walled and tubular structures which start from the hilum of the kidneys, run downward and open in urinary bladder. Ureters conduct the urine from the kidneys to urinary bladder by peristalsis. Urinary bladder. The urinary bladder is thin-walled, elastic, pear-shaped and distensible sac present in lower part of abdomen. Bladder is a temporary storage sac of urine. The urinary bladder is lined with smooth muscles, so it is under nervous control. As a result, we can usually control the urge to urinate. Urethra. Urethra is a muscular and tubular structure which extends from the urinary bladder to the outside. Urethra carries the urine to outside body. Bowman's capsule. Bowman's capsule is a double-walled cup present in the renal cortex. It is lined by a thin and semi-permeable epithelium of flat cells. There is a group of blood capillaries called glomerulus in the cavity of Bowman's capsule. Glomerulus is formed by the division of afferent arteriole. Bowman's capsule and glomerulus are collectively called Malphian body or renal corpuscle. Glomerulus is the site of filtration under pressure called ultrafiltration. The filtrate formed by glomerulus is therefore known as glomerular or nephric filtrate. Nephric tubules. Nephric tubule is long and coiled and is formed of three parts: proximal convoluted tubule PCT, loop of Henle, distal convoluted tubule DCT. Proximal convoluted tubule PCT is a convoluted part of the kidney and lies in the renal cortex. It is the main site of selective reabsorption of sodium, calcium, amino acids, etc. from the nephric filtrate. Loop of Henle is a U-shaped tubule present in the renal medulla. It is formed of two limbs, descending limb which is thin-walled and ascending limb which is thick-walled. Descending limb is permeable to water but impermeable to minerals like sodium chloride. Ascending limb is permeable to minerals like sodium chloride but impermeable to water. It concentrates the urine. Distal convoluted tubule DCT is a convoluted part and lies in the renal cortex. It opens in the collecting tubule. Most of water from the nephric filtrate is reabsorbed through the wall of DCT and collecting tubule. Formation of urine. The purpose of making urine is to filter out waste products from the blood. Just as CO2 is removed from the blood in the lungs, nitrogenous waste such as urea or uric acid are removed from blood in the kidneys. It is then no surprise that the basic filtration unit in kidneys, like in the lungs, is a cluster of very thin-walled blood capillaries. Each capillary cluster in the kidney is associated with a cup-shaped end of a tube that collects the filtered urine. Some substances in the initial filtrate, such as glucose, amino acids, salts, and a major amount of water, are selectively reabsorbed as the urine flows along the tube. The amount of water reabsorbed depends on how much excess water there is in the body and on how much of dissolved waste there is to be excreted. Urine is stored in the urinary bladder until the pressure of the expanded bladder leads to the urge to pass it out through the urethra. Artificial kidney, hemodialysis. Kidneys are vital organs for survival. Several factors like infections, injury, or restricted blood flow to kidneys reduce the activity of kidneys. This leads to accumulation of poisonous wastes in the body, which can even lead to death. In case of kidney failure, an artificial kidney can be used, which is a device to remove nitrogenous waste products from the blood through dialysis. Artificial kidneys contain a number of tubes with a semi-permeable lining suspended in a tank filled with dialysing fluid. This fluid has the same osmotic pressure as blood, except that it is devoid of nitrogenous wastes. The patient's blood is passed through these tubes. During this passage, the waste products from the blood pass into dialysing fluid by diffusion. The purified blood is pumped back into the patient. This is similar to the function of the kidney, but it is different since there is no reabsorption involved. Normally, in a healthy adult, the initial filtrate in the kidneys is about 180 litre daily. However, the volume actually excreted is only a litre or 2 a day because the remaining filtrate is reabsorbed in the kidney's tubules. Excretion in plants. Plants use completely different strategies for excretion than those of animals. Oxygen itself can be thought of as a waste product generated during photosynthesis. We have discussed earlier how plants deal with oxygen as well as carbon dioxide. They can get rid of excess water by transpiration. For other wastes, plants use the fact that many of their tissues consist of dead cells and they can even lose some parts such as leaves. Many plant waste products are stored in cellular vacuoles. Waste products may be stored in leaves that fall off. Other waste products are stored as raisins and gums, especially in old xylem. Plants also excrete some waste substances into the soil around them. Assessment. Drag and drop the options in the appropriate boxes. Did you know? Micturition is expelling of urine from body. It is commonly called urination. In diabetes, urine has excess of sugar called glycosuria. Normal human excretes 1.5 to 1.8 liters of urine per day. In female, urethra carries only urine, while in male, urethra carries both urine and sperms, so is also called urinogenital canal. Summary. Let us summarize what we have learned. Excretion involves expelling of nitrogenous wastes, while osmoregulation is regulating the water level in the body fluids. Different animals have different excretory organs, while lower organisms have body surface excretion. Excretory system of man is formed of kidneys, ureters, urinary bladder, and urethra. Kidneys have excretory units called nephrons. Each nephron is formed of Bowman's capsule and nephric tubule. Bowman's capsule has glomerulus, where ultrafiltration occurs, while nephric tubules show differential reabsorption. Hemodialysis is a process of separating nitrogenous wastes from the blood of a person with kidney dysfunctioning with the help of artificial kidney. In plants, oxygen and excess water is released through stomata.
Introduction. As we already know that body of higher animals like man is formed of a number of organ systems. Yes, some of the examples are digestive system, respiratory system, circulatory system, excretory system, etc. So we can say that each system is specialized to do a specific function such as nutrition, digestion, respiration, transport of materials, excretion, respectively. In each system, all the organs work together so that whole of the system can work properly. Yes, in other words, we can say that all the organs of a system coordinate with each other so that the system can work properly. Coordination is the working together of the various organs in a systematic manner so as to produce a proper reaction to the stimulus. As we already know that something is called living when a movement is observed in it. This movement can be due to growth, as in plants, a seed germinates and grows. This movement in plants is stopped after a particular time. Yes, on the other hand, in animals and some plants, these movements are not connected with growth. Some examples of it are running of a dog, playing football of children, and chewing cud of cows. These movements are not related to growth. If we analyze these movements, we find a reason behind each and every movement. The dog may be running because it has seen a cat. Children play to have pleasure. Cows chew cud to help break up tough food so as to be able to digest it better.
Objectives. At the end of this lesson, you'll be able to understand coordination in animals and plants, find out what is stimulus, find out nervous coordination in lower animals, understand nervous coordination in higher animals, find out the unit of nervous system, neuron, find out types of neurons, find out types of nerve fibers, understand nervous system of man, understand structure and functions of central nervous system, human brain, find out structure and functions of spinal cord, understand structure and functions of peripheral nervous system, find out structure and functions of autonomic nervous system, understand reflex actions. Stimulus. While playing football, there is coordination between eyes for observation of ball, brain for analyzing these observation, and muscles for giving proper response and movement to the ball. Thus, we can say that every living organism respond and react to changes in the surroundings. The changes in the environment to which the organisms respond and react are called stimuli. Stimulus are of two types: external stimulus and internal stimulus. External stimulus is due to environmental factors like heat, light, sound, water, wind, etc. Internal stimulus occurs within the organism. It may be due to hormones, acids, enzymes, etc. present within the organism. Coordination in animals. In all the animals belonging to coelenterate to Mammalia, multicellular control and coordination of body function is enabled by specialized cells called neurons. In higher metazoans, these neurons or nerve cells are organized to form a nervous system. In animals belonging to Arthropoda to Mammalia, there is endocrine system also in addition to nervous system. The nervous and endocrine systems are collectively called neuroendocrine system. Nervous coordination in lower animals. In coelentrates, nervous system is of diffused type. Examples: Hydra. In Platyhelminthes,
ladder-type nervous system is present. Examples: tapeworm, liver fluke, etc. In annelids, a well-organized centralized nervous system is present. This consists of a circumpharyngeal nerve ring and a nerve cord. In Arthropoda, centralized nervous system like annelids is present, but their nerve ring is circumesophageal. Nervous coordination in higher animals. In higher organisms, 3 types of systems coordinate with one another to control and coordinate the body functions. They are receptor systems, nervous system, effector system. Receptor systems is formed of receptors or sense organs. These receptors are made up of highly specialized cells which receive stimuli and change them into appropriate nerve impulse, which are carried to CNS by nerve fibers of sensory nerves. Receptors are of 6 main types. Photoreceptors for light located in eyes. Phonoreceptors for sound located in internal ears. Olfactoreceptors for smell located in nasal chambers. Gustatoreceptors for taste located in taste buds on tongue. Tangoreceptors for touch located in skin. Thermoreceptors for changes in temperature located in skin. Nervous system analyzes the sensory nerve impulses and initiates the appropriate motor nerve impulses which are carried to appropriate effector organ by nerve fibers of motor nerves. Effector system is formed of effector organs which include muscles and glands and give the response. Example: contraction or relaxation of muscles and switch on or switch off of glandular secretion. Nervous system of man. The function of nervous system is to coordinate the activities of our body. It is the control system of all our actions, thinking, and behavior. The nervous system helps all other systems of our body to work together. The human nervous system receives information from the surroundings, processes it, interprets it, and then responds accordingly. The nervous system also passes information from one internal system to another. Example: as soon as we put food in our mouth, it immediately causes the release of saliva from the salivary gland. Human nervous system is composed of 3 parts: central nervous system, CNS, peripheral nervous system, PNS, autonomic nervous system, ANS. Neuron. The units which make up the nervous system are called nerve cells or neurons. Neuron is a functional and structural unit of nervous system. A neuron is a nerve cell with all its branches. Neuron is the longest cell in the human body and is about 100 centimeters long. A neuron is formed of 3 parts: cyton, dendrites, axon. Cyton. Cyton is a typical animal cell type structure which contains cytoplasm and a nucleus. It is spherical in shape and about 4 to 135 μm. It has a granular cytoplasm called neuroplasm which is enclosed by cell membrane called neurolemma. It also has a large spherical and centric nucleus with a nucleolus. It has all cell organelles like mitochondria, Golgi bodies, lysosomes, ribosomes, etc. It has also a number of small-sized granules, Nissel's granules, which help in protein synthesis. Dendrites. Dendrites are small-sized branched fibers, many in number. They conduct stimuli to its cell body, hence called afferent in nature. Axon. Axon is actually the largest cell in the body. They are long-sized fibers. They are unbranched and only 1 in number. They conduct stimuli from cell body towards other neurons, hence it is called efferent in nature. They have one or two additional covering. Myelin sheath, Schwann's sheath. Myelin sheath around the axon is an insulating and protective sheath. At certain places, myelin sheath is absent, and that area is known as node of Ranvier. Schwann sheath covers whole of the axon. It also covers myelin sheath. Axon bears terminal and fibers which end into synaptic knobs. Types of neurons. On the basis of their functions, neurons are of three types: sensory, association, relaying, motor. Sensory neurons are found in sense organs. Association, relaying neurons are found in brain and spinal cord. Motor neurons are also found in brain and spinal cord. Functions of neurons. Sensory neurons conduct nerve impulse from sense organs to the central nervous system, that is, brain and spinal cord. Relaying neuron is present in the CNS, receives these stimuli brought by sensory neurons, analyzes it, interprets it, and produces a message. Motor neurons conduct this message from CNS to the effectors. Central nervous system, human brain, consists of brain and spinal cord in animals. All life activities are under control of the brain. Human brain. Brain is a soft, whitish, large and slightly flattened structure present in the cranial cavity of cranium. Weight of brain is about 1200 to 1400 gram. Human brain is covered with three meninges or membranes. Pie is inner meninges, arachnoid is middle meninges, and dura mater is outer meninges. The space between membranes is filled with cerebrospinal fluid. Brain has gray matter outside and white matter inside. Parts of brain. Human brain has three parts: forebrain, midbrain, hindbrain. Forebrain is anterior, two-third part of brain. It is main thinking part of brain. It has three parts. Olfactory lobe are one pair, small-sized, club-shaped. Cerebrum is the largest part of brain and forms about 80% of weight of brain. It has one pair of cerebral hemisphere. Each has four lobes: frontal lobe, parietal lobe, temporal lobe, and occipital lobe. Diencephalon is made of thalamus and hypothalamus. Midbrain is formed of two parts. Optic lobes, cerebral peduncles. Hindbrain also has three parts: cerebellum, pons, medulla oblongata. Functions of different parts of human brain are as given in this table. Spinal cord. Spinal cord controls the reflex actions and conducts messages between different parts of the body and brain. Peripheral nervous system. Peripheral nervous system consists of nerves arising from the brain, cranial nerves, and nerves arising from the spinal cord, spinal nerves. It assists in transmitting information between central nervous system and the rest of the body. Autonomic nervous system. Autonomous nervous system. Parasympathetic and sympathetic system. Involuntary activities like breathing and beating of heart take place by the coordinated efforts of the medulla oblongata and autonomous nervous system. Reflex actions. When a receptor is stimulated, it sends a signal to the central nervous system where the brain coordinates the response. But sometimes a very quick response is needed one that does not need the involvement of the brain, this is a reflex action. Reflex actions are rapid and happen without us thinking. Example, you would pull your hand away from a hot flame without thinking about it. The process is as follows. A receptor detects a stimulus. This is indicated by the red on the hand. A sensory neuron sends a signal to the relay neuron. Then relay neuron sends the signal to the motor neuron. Then motor neuron sends a signal to the effector. Then effector produces a response. As a result, the hand is pulled away quickly.
Assessment. Before proceeding further, let us know how much have you learned. Drag and drop the correct option.
Did you know? Brain is the highest coordination center in human body. Hypothalamus is commonly known as thermostat of the body. Meningitis is the inflammation of meningeal membranes. Cerebellum is also known as little brain. Summary. Let us summarize what we have learned. Control and coordination are the functions of the nervous system and hormones in human body. The responses of the nervous system can be classified as reflex action, voluntary action, or involuntary action. The nervous system uses electrical impulses to transmit messages. The nervous system gets information from our sense organs and acts through our muscles. Chemical coordination is seen both in plants and animals. Hormones produced in one part of an organism move to another part to achieve the desired effect. A feedback mechanism regulates the action of hormones.
Introduction. As we already know that plants do not have a nervous system and sense organs like eyes, ears, or nose like the animals have. Yes, but they can still sense things like light, gravity, chemicals, water, and touch by actions of hormones on them. So we can say that plants can sense the presence of stimuli and respond to them. We can also say that the hormones in plants coordinate their behavior by affecting the growth of a plant. Yes, and the effect on growth of the plant can result in the movement of a part of a plant like root or stem. The plants respond to various stimuli very slowly by growing.
Objectives. At the end of this lesson, you'll be able to understand coordination in plants, find out immediate response to stimulus, understand movement due to growth, find out hormones in plants, study photoperiodism and flowering, find out hormones in animals, and understand structure and functions of endocrine glands. Coordination in plants. Plants lack nervous and muscular system. Plants respond to stimuli by showing two types of movements, growth-independent and growth-dependent. Growth-independent movements are usually quicker than growth-dependent ones and involve the use of electrochemical signals by the plant. Example: drooping of leaves of a touch-me-not plant when it is touched. Immediate response to stimulus. The movement of plants in the direction of stimulus is known as tropism. Tropic movements are shown in response to environmental factors such as light, gravity, water, and chemicals. Growth-dependent movements or tropic movements are slow, occurring either towards or away from the stimulus. Phototropism is directional movement of a plant part in response to light. Example: shoots show positive phototropism. Plant roots are negatively phototropic, whereas plant shoots are positively phototropic. Geotropism is directional movement of a plant part in response to gravity. Example: roots show positive geotropism. Plant roots are positively geotropic, whereas plant shoots are usually negatively geotropic. Chemotropism is directional movement of a plant or plant part in response to chemicals. Example: growth of the pollen tube towards the ovule. Hydrotropism is movement of a part of a plant in response to water. Example: roots. Movement due to growth. When a tendril comes in contact with the support, then the part of the tendril away from the support grows more rapidly than the part of the tendril that is in contact with the object. Thus, the tendril circles around the object and appears to cling to it. Hormones in plants. Plant hormones or phytohormones are chemical substances produced naturally by plants. They are capable of being translocated and regulate one or more physiological processes when present in low concentrations. Plant hormones and their functions are as given in table. Photoperiodism and flowering. Flowering in a plant occurs at a particular time of the year and is controlled by factors like photoperiod and temperature. The response of plants to the relative lengths and alternations of light and dark periods with regard to initiation of flowering is called photoperiodism. It was discovered by Garner and Allard in 1920. On the basis of photoperiod, plants are of three types: short-day plants, long-day plants, day-neutral plants. Short-day plants require longer dark period for flowering. Example: tobacco, rice, dahlia. Long-day plants require longer light period for flowering. Example: wheat, oat, radish, lettuce. Day-neutral plants are not dependent on photoperiod for flowering. Example: tomato, sunflower. Assessment. Before proceeding further, let us know how much have you learned. Match the following. Hormones in animals. The term hormone was introduced by Bayliss and Starling. The hormones in animals are produced by the endocrine glands and are chemical substances that control and coordinate activities of living organisms and also their growth. Animal hormones do not bring about directional growth depending on environmental cues, but promote controlled growth in various areas to maintain the body design. Animal hormones and their functions and deficiency diseases are as given in table. Endocrine glands. There are a number of endocrine glands which differ from one another in their location, structure, as well as in the hormones secreted by them and their functions. Endocrine system is formed of a number of endocrine glands and control and coordinates the body functions through their specific chemical secretions called hormones. Did you know? Thyroid gland is the largest endocrine gland of the human body. Deficiency of thyroxine in infants causes cretinism, characterized by reduced physical, mental, and sexual growth. Deficiency of iodine in the diet causes goiter, which is characterized by swollen neck. Adrenaline is also called emergency hormone or triple F hormone.
Pituitary gland is commonly known as master gland. Deficiency of growth hormone GH causes dwarfism, while its excess causes gigantism. Deficiency of insulin causes diabetes. Summary. Let us summarize what we have learned. Plants do not only respond to light, but show tropisms in response to other stimuli as well. Phytohormones are of different types: auxin, gibberellins, cytokinin, abscisic acid, and ethylene. Flowering and seed germination in plants are regulated by the duration of light. This is known as photoperiodism. Phototropism is the movement of the body parts of plants in relation to direction of light stimuli. Geotropism is the movement of the body parts of plants in relation to gravitational pull of the earth. Hydrotropism is the movement of the body parts of plants in the direction of water. Endocrine system is formed of endocrine or ductless glands whose secretions are called hormones. Thyroid gland secretes thyroxine hormone and its deficiency causes cretinism. Parathyroid secretes PTH, which regulates calcium-phosphorus balance inside the body. Adrenal glands secrete two hormones, corticoids and adrenaline. Hypothalamus secretes releasing hormones which regulate hormonal secretions from anterior lobe of pituitary. Pancreas also secretes two hormones, insulin and glucagon, which regulate glucose level in blood. Testes secrete testosterone and ovaries secrete estrogen and progesterone.
Introduction. We know that reproduction is the ability of all organisms to produce young ones similar to themselves in most of characters. Yes, we can also say the process by which species is continued is called reproduction.
Objectives. At the end of this lesson, you'll be able to define reproduction, find out importance of variation, identify types of reproduction, understand the asexual reproduction, understand fission, study the process of budding, understand process of spore formation, understand regeneration, understand process of fragmentation, find out vegetative reproduction, exact copies of organisms. Various organisms of a species look similar because their designs are similar. By the process of reproduction, the blueprints of the body design are produced. We already know that every organism is made up of cells and each cell has chromosome in nucleus. These chromosomes bear information for transmission of characters from parents to their offsprings in the form of DNA. DNA carries information for the formation of proteins. After each cell division, DNA is replicated and two copies are produced. As a result of cell division, each cell is divided into two daughter cells. Importance of variation. At the time of copying, when there is change in DNA information, then the proteins formed are different and hence there occurs variation from the parent species, which is the basis of evolution. Niches are filled up by populations of organisms as a result of process of reproduction. Due to external factors like change in temperature, water level, meteorite hits, etc., there is drastic change in niche. As a result, entire population perishes. But there are chances that few individuals may survive. We can understand above discussion with the help of an example. If water temperature of bacteria living in temperate water increases due to global warming, most of the bacteria perishes. Few variants which are resistant to heat may survive and flourish. So we can say that variation is important for survival of species. Types of reproduction. Asexual reproduction. Reproduction is of two types. Asexual reproduction. Sexual reproduction. The production of a new organism from a single parent without the involvement of sex cells is called asexual reproduction. Example, binary fission in amoeba, budding in hydra, spore formation in rhizopus, and vegetative reproduction in flowering plants. In asexual reproduction, cell divisions are amitotic or mitotic. The new individuals produced are genetically identical to their parents, and it is fast mode of multiplication. The disadvantages of asexual reproduction are that identical organisms are produced generation after generation, and evolutionary changes are not possible as variation does not occur. Fission. In fission, a fully grown parent divides into two or more daughters. It is the simplest method of asexual reproduction in unicellular organisms such as amoeba, paramecium, and other protozoa. Fission is of two types: binary fission, multiple fission. Binary fission is the division of one cell into two similar or identical cells during favorable conditions. In this method, the nucleus first divides amitotically into two, followed by the division of the cytoplasm. The cell finally splits into two daughter cells. Examples: bacteria, yeast, euglena, amoeba, and paramecium. Multiple fission is parental fission. Parental body divides into many daughter cells simultaneously during the unfavorable conditions. The nucleus of the cell divides repeatedly, producing many nuclei. Each nucleus is surrounded by a small amount of cytoplasm, and many daughter cells are produced within cyst. The cyst breaks up under favorable conditions, and small offsprings are liberated. Example of multiple fission is that of malaria parasite Plasmodium. Budding. In budding, one or more unicellular or multicellular outgrowths, called buds, are formed on or inside the parental body. Hydra reproduces by budding using the regenerative cell division at one specific site. When fully mature, the bud detaches itself from the parent body and develops into new independent individuals. Spore formation. When a slice of bread is kept in moist and dark place for few days, spores of rhizopus present in the air settle on the bread to form new fungus plants of rhizopus. The rhizopus has a knob-like structure which is involved in reproduction called sporangia, containing spores that develop into new rhizopus. Regeneration. The process of getting back a full organism from its body parts is called regeneration. It is the ability of a fully differentiated organism to give rise to new individual organisms from its body parts. Small cut or broken parts of the organism's body grow or regenerate into separate individuals. Simple organisms like Hydra and Planaria can be cut into any number of pieces, and each piece grows into a complete organism. Fragmentation. In fragmentation, parental body breaks into two or more fragments, either by wave action or by death or decay of older parts. Multicellular organisms with simple body organizations such as filamentous algae Spirogyra breaks up into two or more small pieces or fragments upon maturation. These fragments grow into new individuals. Among animals, flatworms show fragmentation of the body which develops into new individuals. Fragmentation is found in algae such as Spirogyra. Vegetative reproduction. Vegetative reproduction is process of multiplication in which new plants are obtained from the parts of old plants like stems, roots, and leaves without the help of any reproductive organ. Vegetative propagation is of two types: natural vegetative propagation, artificial vegetative propagation. Natural vegetative propagation. Among seed plants, natural vegetative propagation is very common. It is of three types: by roots, by stem, and by leaves. By roots. Some plants develop adventitious buds on them. Example, guava, shisham. Some tuberous adventitious roots, besides possessing adventitious buds, also contain sufficient quantities of food. Example, dahlia and sweet potato. By stem. Some plants reproduce by means of stem straggling, and branched rhizomes reproduce by vegetative reproduction. Example, banana, ginger, turmeric. Stem tubers are found in potato and artichoke. Tuber of potato is a swollen apical part of an underground stem branched, bears a number of nodes or eyes. Each eye bears one or more buds. New plants are produced from the buds on the eyes. The potato crop is raised by tubers and not by seeds. Runner is aerial weak stem, for example in lawn grass, mint, and wood. Sorrel, when touches the ground, gives off adventitious roots at nodes. When the older part of plant dies, the branches separate from the parent plant and form independent plants. A bulb also bears a number of buds, example, garlic and onion. Corms like crocus, colocasia, etc. have sufficient stored food and also bear many adventitious buds. By leaves. In some plants, notched margins of fleshy leaves bear adventitious buds. When the leaf falls on the soil, the buds develop into small plants under favorable condition. These plantlets, on being detached, develop into independent plants. Example, Bryophyllum, begonia.
Assessment. Before proceeding further, let us know how much have you learned. Drag and drop the correct option.
Artificial vegetative propagation. Gardeners and horticulturists have developed the various methods of artificial vegetative propagation. Some common methods are by cutting, layering, grafting, budding, tissue culture. Cutting. A cutting is separated portion of root, stem or leaf which is buried partly in moist soil. Many plants like sugarcane, rose, citrus, duranta, grapes, cocoa, bougainvillea, carnations and chrysanthemum are propagated by means of cutting. Layering. The adventitious roots are produced in the branch of the stem before the plant is detached from the parent plant. The branch of stem is called a layer and phenomenon is called layering. This method is used in lemon, guava, hibiscus, bougainvillea, jasmine, raspberry, and many ornamental plants. Grafting. In this method of reproduction, two plants of closely related varieties are joined together so that they live as one plant. The portion of a plant that is grafted on the other plant is called scion, and the plant in which grafting is performed is called the stalk. Examples: mango, apple, peas, citrus, and guava. Budding. In budding, a bud with small portion of surrounding bark is taken from the stem of a desired plant. It is then inserted into a small slit made in the bark of stalk. Both are tied together and not allowed to dry. Example, rose, plums, etc. Tissue culture. It is the production or propagation of new plants from isolated plant cells or small pieces of plant tissue in a synthetic medium of culture solution. Plants are grown by removing tissues or separating cells from the growing tip of the plant and put in an artificial medium. The plant tissue divides to form a small group of cells called callus. The callus is transferred to another medium containing hormones for growth and differentiation that forms plantlets. The plantlets produced are transplanted into pots or soil where they can grow to form mature plants. It is also known as micropropagation in vitro because it takes place outside the parent plant body in a test tube using an artificial environment. It is being used for the production of ornamental plants like orchids, dahlia, and carnation. Advantages and disadvantages of vegetative propagation. Let us discuss some of the advantages and disadvantages of vegetative propagation.
Assessment. Before proceeding further, let us know how much have you learned. Match the following.
Did you know, during multiple fission in liver, Plasmodium produces about 1000 daughter cells, while during multiple fission inside the red blood corpuscles, it produces 12 to 24 daughter cells called merocytes. Reparative regeneration is the process of reformation of damaged cells of the body. Example, wound healing and replacement of dead RBCs by new RBCs in man. Regenerative regeneration is the process of redevelopment of lost body part. Example, tail in lizard, hydra, planaria, etc. Bulbils are small, fleshy, specialized buds. When they fall on the ground, they produce new individuals. Summary. Let us summarize what we have learned. The process in which new organisms are formed by existing organisms is called reproduction. In asexual reproduction, new individual comes from single parent. Some organisms like Spirogyra, upon maturation, break up into smaller fragments which grow into new individuals. In plants like money plant, rose, grapes, etc., vegetative propagation is done by cutting. In layering, a branch of plant bearing the tips of the branch exposed is bent towards ground and covered with moist soil. Grafting is a method in which cut stems of two different plants, stalk and chignon, are joined together in such a way they develop into single plant. Various methods of asexual reproduction found in animals are fission, budding, fragmentation, and regeneration. Fission involves division of the parental organism into two or more daughter cells. Fission is of two types, binary and multiple fission. In binary fission, two daughter cells are formed. In multiple fission, many daughter cells are formed. Budding involves formation of one or more unicellular or multicellular buds on or inside the parental body. Buds are unicellular in yeasts, while are multicellular in hydra, sponges, etc. Buds may be exogenous or endogenous. Fragmentation involves breaking of parental body into two or more fragments, each of which develops into an organism. Regeneration involves repair of damaged tissues or redevelopment of several body parts or formation of whole body from a body fragment. The power of regeneration is more in lower organisms due to less specialization in them.
Introduction. As we have already discussed that reproduction is the ability of all organisms to produce young ones similar to themselves in most of characters. Yes, Madhuri, and the process which involves fusion of male and female gametes to form a new individual is known as sexual reproduction.
Objectives. At the end of this lesson, you'll be able to define sexual reproduction, understand the sexual reproduction in flowering plants, understand structure of flower, identify structure and types of seeds, understand structure of unisexual flower, identify structure of bisexual flower, understand structure of neuter flower, identify monoecious and dioecious plants, understand functions of flower, identify structure and types of inflorescence, understand process of pollination and its types, understand process of fertilization, identify structure of ovule, understand process of syngamy, understand process of triple fusion, understand process of double fertilization. Significance of sexual mode of reproduction. Sexual reproduction promotes diversity of characters in the offsprings. It results in new combination of genes brought together in the gamete, and this reshuffling increases genetic variation. It plays a prominent role in the origin of new species of combining DNA from two individuals during reproduction. Sexual reproduction in flowering plants. In the early stage, the plants are just leafy or in vegetative phase, and when they grow and reproduce or are in reproductive phase, the flowers are born. Therefore, we can say that flowers are the reproductive parts of plant body. The flower. A flower is brightly colored reproductive part of a plant. The stalk of flower is called pedicel. Swollen flat tip of pedicel forms the thalamus. The four types of floral leaves, sepals, petals, stamens, and carpel appear from thalamus. Sepals and petals are non-essential parts of a flower for reproduction, while stamens and carpels constitute the essential parts of a flower and contain the germ cells. Sepals or calyx are green and form the outermost whorl of flower. Petals or corolla lie next to sepals. They are usually colored to attract the insects for pollination. Stamens or androecium are next to petals. Each stamen is made up of stalk-like filament and flattened knob like anther. Anther bears pollen sacs which produce pollen grains. Stamens represent the male part of the flower. Carpel or gynoecium is the female part of flower and forms the central part of a flower. Carpel shows basal swollen ovary, middle elongated style, and upper knob-like part called stigma. Ovary bears ovules, which are converted into seeds. The fruits encloses and protect seeds. Seeds. Seeds are matured ovules. Seeds contain an embryo and reserve food which is used by developing embryo at the time of seedling formation. A mature seed is made up of two important parts: seed coat, embryo. Seed coat is hard layer which protects the internal parts of seed. Embryo is made up of radicle, plumule, and cotyledons. Radicle forms young root and plumule forms young shoot. Seeds are monocotyledonous when they have one, or dicotyledonous when they have two cotyledons. Seeds may be endospermic when they have endosperm, or non-endospermic when they do not have endosperm. Activity. Let us conduct an activity to clearly understand the structure of seed. We will soak few seeds of Bengal gram and few seeds of maize and keep them overnight. Next day morning we will drain the excess water and cover these seeds with wet cloth for a day. Next day we will cut open both types of seeds into halves. We observe that Bengal gram seed has seed coat, radicle, plumule and two cotyledons, while maize seed has seed coat, radicle, plumule and one cotyledon. Unisexual flowers. Flowers that bear either stamen or pistil are called unisexual. Example: papaya, watermelon. Bisexual flowers. Flowers that contain both stamen and pistil are termed as bisexual or hermaphrodite. Example: pea, hibiscus and mustard. Neuter flowers. Plants in which flowers lack both stamen or pistil are known as neuter. Example: mango, cashew. Monoecious and dioecious plants. Plants that bear both types of unisexual flowers are called monoecious plants. Example: maize, cucurbit and castor. Plants that bear one type of unisexual flowers are called dioecious plants. Example: date palm, mulberry. Functions of a flower. Flower bears male sex organs stamen and female sex organs carpels. Flower is the part of the plant that takes part in sexual reproduction. Ovary matures to form fruit and contains seeds. Inflorescence. Flowers do not always occur singly. The flowers, which are small in size, often occur in clusters. An axis bearing a cluster of flowers is known as inflorescence. It may be terminal or axillary. Cauliflower is a very good example of inflorescence. Pollination. A new seed of the plant is formed when male gamete present in a pollen grain unites with the female gamete present in the ovule. Pollination is the transfer of pollen grains from the anther of a stamen to the stigma of a carpel. The pollen grains are transferred by many agents such as insects, birds, man and water. Pollination is of two types: self-pollination, cross-pollination. When the pollen grains from anther of a flower are transferred to the stigma of the same flower or another flower of same plant, it is known as self-pollination. When the pollen grains from anther of a flower are transferred to the stigma of another flower of another plant of same species, then it is known as cross-pollination. Fertilization. After a pollen grain falls on stigma, the next step is fertilization. Fertilization is the fusion of male and female gametes to form a zygote. During sexual reproduction, this happens in following steps. When a pollen grain falls on the stigma of the carpel, It bursts open and grows a pollen tube downwards through style towards the female gamete in the ovary. Two male gametes are formed in pollen tube. A male gamete moves down the pollen tube. The pollen tube enters the ovule in the ovary. The tip of the pollen tube bursts open and male gamete comes out of the pollen tube. In ovary, the male gamete of pollen combines with the nucleus of female gamete or egg present in ovule to form a fertilized egg called zygote. After fertilization, the zygote divides several times to form an embryo within the ovule. The ovule then develops a tough coat and gets converted into a seed. The seed is the reproductive unit of a plant. It contains a future embryo which develops into seedling. Ovule. A minute structure in seed plants containing the embryo sac and surrounded by the nucellus, which develops into a seed after fertilization. It consists of three parts: the integuments forming its outer layers, the nucellus or megasporangium, and megaspore-derived female gametophyte or megagametophyte in its center. The megagametophyte, also called embryo sac in flowering plants, produces an egg cell or several egg cells in some groups for fertilization. After fertilization, the ovule develops into a seed, syngamy. One of the male gamete fuses with egg to form diploid zygote. It is called syngamy. Triple fusion. Second male gamete fuses with secondary nucleus to form primary endosperm nucleus. This is called triple fusion because three nuclei are involved in the fusion process: one male gamete and two polar nuclei. Double fertilization. The process of fertilization, which occurs twice in the same embryo sac at a time by two male gametes, syngamy and triple fusion, is called double fertilization. Did you know pollination by birds is called ornithophily? In hydrophilous flowers, pollen grains are light but covered with wax. Edible pollen are produced by Rosa, Magnolia and
Clematis.
Zostera bear longest pollen about 2500 μm long, while smallest pollen is of Myosotis about 2.5 to 3.5 μm long. Erythrina is pollinated by crows and squirrels. Hay fever is caused due to allergic reaction to the presence of pollen in air. Parthenogenesis is defined as a development of egg without fertilization. Process of fruit without fertilization is called parthenocarpy. Summary. Let us summarize what we have learned. The reproductive parts of a higher plant are located in a flower. Stamen is the male reproductive part of a plant. Carpel is present in the center of a flower and is the female reproductive part. The transfer of pollen grains from anther to stigma is called pollination. Pollination is of two types: self-pollination and cross-pollination. The ovary ripens to form a fruit. The fruit dehisces to release the seeds. Each seed contains a future plant and on germination produces a new individual.
Introduction. As we have already discussed that reproduction is the ability of all organisms to produce young ones similar to themselves in most of characters. Yes, and the process which involves fusion of male and female gametes to form a new individual is known as sexual reproduction.
Objectives. At the end of this lesson, you'll be able to define sexual reproduction, understand the sexual reproduction in human beings, understand puberty, identify changes at maturity, identify male reproductive organs, identify female reproductive organs, understand process of reproduction in human beings, understand menstruation, sexual reproduction in human beings. Human beings are unisexual or dioecious. Two sexes are also different in certain external morphological features called secondary sexual characters, which is called sexual dimorphism. In human beings, the reproductive organs, testes in male and ovary in female, becomes functional only after attaining sexual maturity, puberty or sexual maturity. Puberty is the period of sexual maturity during adolescence when reproductive organs become functional. In human, male sexual maturity is attained at the age of 13 to 14 years, while in females at the age of 10 to 12 years. The testes and ovaries produce viable gametes and also secrete hormones like testosterone from testes in male and estrogen and progesterone from ovary in female. Changes at sexual maturity. Both boys and girls undergo thick hair growth in armpits and genital areas between thighs. Thinner hair on legs, arms and face, and oily skin and appearance of pimples. Among girls, beginning of ovulation from the ovaries and menstrual cycle. Enlargement of breasts due to deposition of fats, darkening of nipple skin, stoppage of growth of bones and height, and maturation of secondary sex organs like fallopian tubes, uterus, etc. Among boys, the germ cells of seminiferous tubules of testes start producing sperms. Secondary sex organs like prostate gland, penis, etc. undergo maturation. Penis becomes enlarged and erect either in daydreams or during night. Penis is required for the actual transfer of sperms from male to female. And broadening of shoulders, deepening of voice, increase in height, etc. Male reproductive system. Male reproductive organs consists of portions that produce germ cells and other portions that deliver the germ cells to the site of fertilization. The human male reproductive organs are testes, epididymis, vas deferens, urethra, penis. Testes. Testes are one pair small-sized, oval-shaped and pinkish-colored organs present in thin-walled skin pouches called scrotal sacs, extra-abdominal in position. Scrotal sacs act as thermoregulators as they keep testicular temperature 1 to 3 degrees Celsius lower than the body temperature for normal spermatogenesis, because the high body temperature may kill the sperm-forming tissues of testes. Testes have about 900 narrow and convoluted seminiferous tubules with sperm-forming germ cells. Germ cells form sperms by spermatogenesis. Epididymis. Epididymis is a coiled tube-like structure firmly attached to the testes and serves as the storehouse of sperms where they become mature and develop motility. Vas deferens. The sperms are carried by long tube called vas deferens or sperm duct into organs called seminal vesicles where the sperms get nourished and stored. Urethra. Urethra is also long, narrow and tubular structure. It is formed by the joining of ejaculatory duct and duct from urinary bladder, so carries both sperms and urine, and is also commonly called urinogenital canal. It passes through penis and opens at its tip. Penis. Penis forms the external male genital organ. It is a cylindrical erectile copulatory organ with thick muscular walls. Its sensitive tip is called glans, which is covered by a retractile skin fold called prepuce. Male reproductive glands. In man there are three types of reproductive glands: seminal vesicles, prostate gland, and Cowper's glands. Seminal vesicles are a pair of thin-walled muscular elongated sac which secretes fluid for nourishment of sperms. Prostate gland is a single, large-sized and lobulated gland present just below the urinary bladder. It produces fluid which is released in the urethra along with secretion of seminal vesicle. Cowper's glands are a pair of white, pea-seed-sized glands present at the base of penis. It secretes alkaline semen, which neutralizes acidity of urine and activates sperms and provides nutrition to the sperms. Sperms. A human sperm is minute microscopic motile and flagellated gamete. It is formed of head, middle piece, and a long and vibratile tail. It fuses with ovum and transmits parental gene to offspring. Assessment.
Before proceeding further, let us know how much have you learned. Drag and drop the correct option.
Female reproductive system. The female germ cells or eggs are made in the ovaries and are responsible for the production of some hormones. The human female reproductive organs are ovaries, fallopian tubes, uterus, vagina. Ovaries. Ovaries are the primary sex organs of female and are one pair, small-sized almond-shaped and whitish structure present in the pelvis of abdomen. Internally, each ovary is with large number of immature primary or ovarian follicles. Ovary forms ova by oogenesis in the germ cells and secretes estrogens and progesterone. Fallopian tubes. Fallopian tubes are one pair of elongated, ciliated, muscular and tubular structures extending from just close to ovaries to uterus. The outer part of each fallopian tube lying close to ovary has a wide aperture called ostium and a number of finger-like processes called fimbriae to receive the ovum released from the ovary. Uterus. Uterus is large-sized muscular and pear-shaped structure present in the pelvis between the urinary bladder and rectum and is the seat of implantation, placentation, and fetal development. Its internal lining is highly vascular and glandular and is called cervix, which opens into the vagina. Vagina. Vagina is a long muscular tubular structure which extends backwards from cervix of uterus and finally opens outside by vaginal aperture in the vestibule. Vagina acts as copulation canal as semen is discharged in it during copulation and birth canal as the baby passes through it during childbirth. Process of sexual reproduction in human beings. The male gamete or sperms are highly active and mobile which move up through cervix into the uterus and then pass into the fallopian tubes. In fallopian tube, only one sperm fertilizes the ovum to form a zygote. This is called fertilization. It occurs only if sperm enters fallopian tube during the ovulatory period. The embryonic development of the zygote starts immediately in the fallopian tube and pregnancy starts while menstruation stops. The embryo moves down to reach the uterus. The embedding of embryo in the thick inner lining of the uterus is called implantation. Then, a special tissue develops between the uterine wall and the embryo called placenta, where the exchange of nutrients, oxygen, and waste products takes place. The time period from the development of fetus inside the uterus till birth is called gestation. The act of giving birth of fully developed fetus at the end of gestation period is termed as parturition. The development of the child inside the mother's body takes approximately 9 months' time. Menstruation. The breakdown and removal of inner, thick, and soft lining of a uterus along with its blood vessels in the form of vaginal bleeding is called menstrual flow or menstruation. The cycle of events taking place in the ovaries and uterus every 28 days, or roughly 1 month, and marked by the menstrual flow is called menstrual cycle or sexual cycle in human female. It lasts for about 2 to 8 days. Assessment.
Before proceeding further, let us know how much have you learned. Drag and drop the correct option.
Did you know sperms form only 10% of the semen? A female lays about 13 eggs in a year, while about 416 eggs during whole reproductive period of human female. Menarche is the beginning of menstruation of puberty, and menopause is period when ovulation and menstrual cycle permanently stops in human female. The average weight of a newly born baby is about 3.5 kilograms. Summary. Let us summarize what we have learned. Human beings are unisexual and show sexual dimorphism. Male reproductive system is formed of testes, epididymis, vas deferentia, urethra, and penis. Accessory reproductive glands of male are seminal vesicles, prostate glands, and Cowper's glands. Female reproductive system is formed of ovaries, fallopian tubes, uterus, vagina, and vulva. Accessory reproductive glands of female are Bartholin's glands and breasts. Menstrual cycle involves cyclic changes occurring in the ovaries and female reproductive tract during the reproductive period. It is completed in about 1 month. It is formed of 4 phases: follicle phase, ovulatory phase, luteal phase, and menstrual phase. It starts at puberty and permanently stops at menopause. Embryonic development involves the series of events which transform zygote into an embryo. It involves phases like gametogenesis, fertilization, cleavage, implantation, placentation, gastrulation, organogenesis, and parturition.
Introduction. As we have already discussed, that reproduction is the ability of all organisms to produce young ones similar to themselves in most of characters. Yes, and for the process of reproduction, we have to make sexual contact. But if we do this without any protection, then many diseases are spread from infected partner. Due to rapid growth in population, we observe population explosion. Yes, it is mainly due to rapid decline in death rate and increase in lifespan.
Objectives. At the end of this lesson, you'll be able to understand significance of reproductive health, identify sexually transmitted diseases, understand methods to control population, understand sex ratio, and identify population size. Reproductive health. Reproductive health is all those aspects of general health which help a person to lead a normal, safe, and satisfying reproductive life. Sexually transmitted diseases.
The diseases which are transmitted by sexual contact from an infected person to a healthy person are known as sexually transmitted diseases. They are caused by various microorganisms that live in warm and moist environments of the vagina, urethra, anus, and mouth. Some of common sexually transmitted diseases are gonorrhea, syphilis, trichomoniasis, AIDS. Gonorrhea is caused by bacterium Neisseria gonorrhea. It is characterized by inflammation of urinogenital tract and the patient feel burning sensation during urination. This bacterium infects the ureter in men and the cervix in women. Syphilis is caused by bacterium Treponema palladium. It is characterized by lesions in the mucous membrane of urinogenital tract and ulcers on genitalia. Trichomoniasis is caused by protozoan Trichomonas vaginalis. It is characterized by some vaginal discharge at the urinogenital tract of the female. AIDS is caused by a virus called HIV, which suppresses the body's immune mechanism and thereby making it susceptible to any disease. Mode of transmission of AIDS is sexual contact, transfusion of blood from an infected person through infected needles used for injection through the placenta from the mother to child during pregnancy. Birth control methods. A number of techniques have been developed to prevent and control pregnancy. They are mainly of three types: mechanical barrier methods, chemical methods, surgical methods. Mechanical barrier methods. In mechanical barrier methods, physical devices such as condoms, diaphragm, and cervical caps are used, which prevents the entry of sperm in the female genital tract during copulation, thus acting as a barrier between them. The use of intrauterine contraceptive devices, IUCDs, prevents implantation in the uterus. This device is a copper T placed safely inside the uterus by a doctor. Chemical methods. In chemical methods, specific drugs are used by females, which are of two types: oral pills, vaginal pills. Oral pills are also called oral contraceptives, which act by changing the hormonal balance of the body so that eggs are not released and fertilization cannot occur. Surgical methods. In surgical methods, a small portion of vas deferens in male removed or tied. It is known as vasectomy, so that vas deferens is blocked, then sperm transfer will be prevented. In female, the fallopian tube is surgically removed or tied. It is known as tubectomy, so that the egg will not be able to reach the uterus, thus fertilization will not take place. Sex ratio. Sex ratio is ratio of number of female to the number of males in a population. The female-male ratio must be maintained for a healthy society. The female child sex ratio is declining at an alarming rate in some sections of our society because of reckless female feticide. Therefore, parental sex determination has been prohibited by law. Population size. Organisms increase their population with the help of reproduction. The rate of birth and death in a given population determines its size. The increase in population occurs when the birth rate is higher than the death rate.
Assessment. Before proceeding further, let us know how much have you learned. Drag and drop the correct option.
Did you know? Exponential phase of human population growth started in 1750 AD. Human population of world is expected to reach 9.5 billion within the next 30 years. India was first country to adopt family planning as the government-sponsored program in 1951. NACO, National AIDS Control Organization. India started a national AIDS control program in 1987. Every year, 1st December is celebrated as World AIDS Day. Summary. Let us summarize what we have learned. Rapid growth of human population is called population explosion. Main causes of it are rapid decline in death rate and increase in longevity. Population explosion results in number of ill effects, so there is an urgent need of population control. Population growth can be prevented by family planning programs, which involve various types of birth control measures like mechanical, chemical, surgical, and natural methods. Sexually transmitted diseases are transmitted during unsafe sexual act. Some commonly occurring STDs are AIDS, chlamydosis, gonorrhea, syphilis, hepatitis B, genital herpes, trichomoniasis, etc. These can be managed and prevented by mutually faithful monogamous relationship and avoiding prostitution, multi-partner sex, and homosexuality.
Introduction. Evolution is any change across successive generations in the heritable characteristics of biological populations. And variations are the structural, functional, or behavioral changes from the normal characters developed in the living organisms.
Objectives. At the end of this lesson, you'll be able to define evolution, understand origin of life, identify acquired and inherited traits, understand speciation, understand evolution and classification, understand tracing evolutionary relationships, identify fossils, understand evolution by stages, identify difference between evolution and progress, understand process of human evolution. Evolution. Evolution is a gradual process through which the present-day animals and plants have arisen since the time life originated. Variation. As we have already discussed that, variations are the structural, functional, or behavioral changes from the normal characters developed in the living organisms. Origin and accumulation of variations are must because these provide raw material for evolution. Types of variation. Variations may be inheritable or non-inheritable. Inheritable variations participate in evolution, while non-inheritable variations do not participate in evolution. On the basis of nature of cells where variations occur, variations are of two types: somatogenic variations or acquired traits, germinal or blastogenic variations. Somatogenic variations that are restricted to the somatic cells of the organism appear any time during the life of an organism, and such variations die along with the organism and are non-heritable. These are variations that are found in the gene pool of an organism. They may be already present in the ancestors or may occur any time. These variations are heritable and form the raw materials for evolution. Sources of variation. Variations are caused due to mutations, genetic drift. Mutations are sudden, large, and inheritable changes in the genetic material. These may be caused by certain natural agents or certain human activities. Genetic drift is the random change in the gene frequency occurring by chance fluctuations. It is inversely proportional to the size of population, so is mostly applicable in small population having high chances of inbreeding and increasing the frequency of homozygosity of harmful genes. It provides diversity without any adaptation. Origin of life. Origin of life is best explained by the Darwin's theory of natural selection. The three main points of this theory are each organism has an ability to survive and reproduce. During reproduction, organism shows variations in many characteristics with their species. Organisms with advantageous characteristics are likely to produce more individuals. The characteristics which help the organisms to survive are inherited by their offsprings and gradually increase generation after generation, or they are naturally selected. Stanley L. Miller and Harold C. Urey in 1953 experimentally proved the formation of simple organic compounds from simpler compounds under reducing conditions in their simulation experiment. Acquired and inherited traits. Inherited characters are those which are controlled by DNA in reproductive cells and are passed on from one generation to another. Any change in such characters results in variations. Acquired characters are those which are acquired by an organism in their lifetime and do not bring any change in DNA and therefore are not passed on to next generation. Speciation. Speciation is a process of forming new species when variations occur in geographically isolated members, which leads to reproductive isolation where members of some species do not reproduce with each other. Migration of members of a population with subtle changes into another population will help in spreading of new traits into new population. Genetic drift, that is, elimination of certain genes from a population due to natural calamity or death, will bring change in gene frequency. Variations also accumulate when inaccuracies occur in the DNA copying mechanism. Change in chromosome number may also cause drastic differences in two subgroups. Sexual reproduction also causes variation. Geographical barrier or geographical isolation, like intervention of river or mountain between two subgroups of population, causes decrease in level of gene flow. Reproductive isolation occurs between two subgroups, which means two subgroups develop traits which do not allow them to mate with each other. Evolution and classification. Similarities among organisms will allow us to group them. The more characteristics two species will have in common, the more closely they are related. The more closely they are related, the more recently they will have had a common ancestor. It can be understood more clearly by the example of a brother and a sister. They are more closely related as their ancestors are common. We can thus build up small groups of species with recent common ancestors, then supergroups of these groups will more distant common ancestors, and so on. Tracing evolutionary relationships. Various biological studies tell us that since their origin, living organisms have been undergoing changes in their organization to evolve into new forms. A number of common features of different kinds of organisms provide evidence in favor of evolution because they can be considered to have evolved from a common ancestor. Some of the important sources which provide evidences for organic evolution are homologous organs, analogous organs. Homologous organs are those organs which have the same basic structure but different functions. Example, forelimbs of a frog, bird, and man. They are built from same basic design of bone, but they perform different functions like jumping, flying, and grasping. Analogous organs are those organs which have different basic structure but same basic functions. Example, wings of insects and birds have different structures but they perform same function of flying. Fossils. The remains of dead animals or plants that lived in the remote past are known as fossils. Ammonite, invertebrate, Nicaea, fish, and Rajasaurus, dinosaur, are some examples of fossils. If we dig the earth and start finding fossils, we find closer to surface are recent than fossils we find in deeper layers. Let us start 100 million years ago. Some invertebrates on the seabed die and are buried in the sand. More sand accumulates and sandstone forms under pressure. Millions of years later, dinosaurs living in the area die and their bodies too are buried in mud. This mud is also compressed into rock above the rock containing the earlier invertebrate fossils. Again, millions of years later, the bodies of horse-like creatures dying in the area are fossilized in rocks above these earlier rocks. Much later, by erosion or water flow, wears away some of the rock and exposes the horse-like fossils. Evolution by stages. A change that is useful for one property to start which can become useful later for quite a different function. Example, feather can start out as providing insulation in cold weather, but later they might become useful for flight. Some dinosaurs had feathers, although they could not fly using feathers. Difference between evolution and progress. In evolution, older species are not eliminated during the formation of new species, and most of older and simpler species still survive. The evolved species are not always better than the parental species. Evolution depends upon natural and genetic drift, which together result in a population which is reproductively isolated from the parental species. Human evolution. As we have discussed earlier, human beings and great apes are closely related species. These had a common ancestor a long time ago. Even in human beings, there occurs a great diversity in form and features across the globe. For a long time, we used to consider these human forms as human races. On the basis of time dating, study of fossils, and molecular phylogeny involving DNA sequences, it is now clear that all human beings belong to single Homo sapiens. Also, the earlier members of Homo sapiens have been traced back to Africa. Some of our ancestors stayed back in Africa and spread across this continent. Others left Africa and slowly spread across planet over a period of time. These groups of ancestors, like other species, lived their lives in the prevailing environment and developed genetic variation to become different colored with specific features in different geographical region. Did you know T. Dobzhansky wrote the book Genetics and Origin of Species? Coagulates are aggregates of complex organic compounds and capable of growth and division by fragmentation and fission. Earliest cells were anaerobic, prokaryotic, and chemoheterotrophic in nature. A.I. Oparin wrote the book Origin of Life in 1936. Herbert Spencer gave the term evolution. Charles Darwin proposed the concept of organic evolution, which propounds descent with modification. Leonardo da Vinci is also known as father of paleontology. W. F. Libby proposed carbon-14 dating technique, also called absolute dating technique. Boltwood proposed uranium-lead method for dating fossils. Neanderthal man was the first civilized man, while Cro-Magnon man is supposed to be extinct representative of modern man. Man is more closely related to chimpanzees than to monkeys because there is 10% difference between DNA of man and monkeys, while 2.5% difference between DNA of man and chimpanzees. Summary. Let us summarize what we have learned. Main sources of variations are mutations, recombination of genes, genetic drift, etc. Mutations are sudden, large, and inheritable changes in genetic material. Mutations act as evolutionary agents and create and maintain variations in a population. Natural selection operates through differential reproduction, due to which useful genetic variability spreads over more and more members of the population. This increases their gene frequency. Genetic drift is the random change in the gene frequency occurring by chance fluctuations. Genetic drift increases the frequency of certain characters having little survival advantage. Charles Darwin proposed theory of natural selection for organic evolution. He proposed that only useful continuous variations help in evolution, and natural selection selects only the best adapted individuals from a heterogeneous population. Most accepted theory of origin of life is chemosynthetic theory. It was proposed by Oparin and Haldane. It states that primitive life originated in water about 4.2 billion years ago by chemical evolution in the primitive reducing environment of Earth. It was experimentally supported by Miller and Urey. Speciation involves origin of new species from the pre-existing species. Speciation may be gradual or instantaneous. Gradual speciation may be allopatric or sympatric, while instantaneous speciation occurs by mutations. Evolutionary relationships can be traced by the classification of organism. Homologous organs appear different and perform different functions but have similar basic structure and origin, while analogous organs have different basic structure but appear similar to perform similar functions. Fossils are petrified remains or impressions of hard parts of extinct organisms preserved in the sedimentary rocks. These are written documents of evolution. Evolutionary relationships may be determined by certain intermediate stages. Example, feathered dinosaurs support the idea that birds are glorified reptiles. A common ancestor may evolve into a number of dissimilar-looking structures. Example, origin of cabbage, cauliflower, kohlrabi, kale, broccoli, etc. from wild cabbage plant. Evolutionary relationship may also be determined by molecular phylogeny, especially blood proteins and amount of DNA changed. Human evolution started in Africa and includes a number of human types like African ape man, Java ape man, Peking man, Cro-Magnon man, and modern man.
Introduction. Heredity is the process of transmission of characters from one generation to another generation. Yes, heredity plays an important role in formation of new species.
Objectives. At the end of this lesson, you'll be able to define heredity, understand the accumulation of variations during reproduction, understand the inherited traits, understand rules for the inheritance of traits, Mendel's contribution, identify law of dominance, understand law of segregation, identify law of independent assortment,
Understand that how these traits get expressed. Understand process of sex determination. The accumulation of variations during reproduction. The difference occurring between parents and their progeny and amongst siblings is called variation. Only those variations are heritable which arise in the germ cells of the organisms. It is either due to combination of genes in chromosomes forming species or due to mutations. Inheritance of characters from parents accounts for similar body design and minute variations. However, diversity is created over succeeding generations in an organism that reproduces sexually. Two individuals from same parents are different. This further gives rise to different progeny. Thus, diversity is created due to accumulation of variations after every generation. Variation constitutes the raw material for evolution, is base of heredity, produces new variants of organism, helps in adaptation of organisms to changed environment, and provides each organism a distinct individuality. Inherited traits. Those traits which are controlled by generic materials and are obtained by parents' inheritance are called inherited traits. Activity. Human ears are of two types: ears with free earlobes, ears with fused earlobes. We can understand the process of inheritance more clearly by observing ears of all the students in the classroom. We find that most of our friends have free earlobe, while some of them have fused earlobes. Rules for the inheritance of traits. Mendel's contribution. The rules of inheritance of traits in human being arose due to the fact that both father and mother contribute practically equal amount of genetic material, that is, DNA, to the child. Thus, each trait can be influenced by both paternal and maternal traits. To study the inheritance of characters over generations, Gregor John Mendel in 1856 used 7 contrasting visible characters of garden peas. Stem height, tall, dwarf plants, seed shape, round, wrinkled seeds, seed color, yellow-green seeds, flower color, violet-white flowers, pod shape, full constricted pods, pod color, green-yellow pods, flower position, axial terminal flowers. A cross between a tall and a dwarf plant is done. Such type of cross which considers only one character is known as monohybrid cross. In the first generation, all the plants were tall. There were no halfway characteristics. In the second generation, both the traits are expressed in a progeny in the ratio 3:1. Based on these experiments, Mendel has proposed 2 laws: law of dominance, law of segregation. Law of dominance. Mendel said that out of 2 contrasting characters in the progeny, only one character is expressed in the F1 generation. The character which is expressed in first generation, that is, tall, is called dominant character, while the character which is not expressed in first generation, that is, dwarf, is called recessive character. Law of segregation. Mendel said that before passing a character into next generation, the genes are first segregated or separated into gametes, which are then reunited to form a diploid zygote. Similarly, in his experiment, Mendel considered 2 characters of seed color: yellow, green, seed shape, round, wrinkled.
Such cross which considers two characters at the same time are called dihybrid cross. In first generation, all the plants have round seeds with yellow color. So, round and yellow are dominant traits, while green and wrinkled are recessive traits. Activity. To confirm that the F2 generation did in fact have a 1:2:1 ratio of TT, TT and TT trait combinations, we will have to self-cross the F2 generation to produce F3 generation. In F3 generation, we find that pure tall, TT produces only tall plants, pure dwarfs, TT produce only dwarf plants, while hybrid tall, TT, produce offspring in 3:1 ratio, 3 tall and 1 dwarf. So we can conclude that tallness is dominant over dwarfness. Law of independent assortment. Each character is independently inherited in the next generation irrespective of the source of character in parent generation. Each gene set is present not as single thread of DNA but as independent pieces called chromosome. Thus, each cell has 2 copies of each chromosome, one each from male and female parent. Each germ cell or gamete will take 1 chromosome from each pair when 2 germ cells combine, ensuring stability of DNA of the species. How these traits get expressed? Each eukaryotic cell contains chromosomes which are long thread made up of DNA. DNA carries a code which instructs the cell about which character is to be expressed in the next generation. A part of DNA which codes for a single character is called a gene. Each cell has 2 copies of each chromosome, one from father and one from mother. Each gamete will take up 1 chromosome from the parent. When 2 chromosomes combine, total number of characters in next generation remains constant, thus ensuring the stability of DNA. Sex determination. Most human chromosomes have a maternal and a paternal copy, and we have 22 such pairs, out of which 1 pair is called sex chromosome. This sex chromosome is not always a perfect pair. Women have a perfect pair of X chromosome, but men have a mismatched pair in which one is normal sizes X chromosome, other is short called Y chromosome. So women are XX and men are XY. During transmittance, mother will always contribute an X chromosome irrespective of sex of child, while chromosome contributed by father will determine the sex of child. A child who inherits X chromosome from father will be a girl, while the child who inherits Y chromosome from father will be a boy. Did you know the term genetics was coined by Bateson in 1906? Mendel is known as father of genetics. Summary. Let us summarize what we have learned. Inheritance from previous generation provides both a common basic body design as well as suitable changes in it for the next generation. The rules of heredity determine the process by which traits are reliably inherited. Both father and mother contribute equal amount of genetic material to the child. Mendel used 7 pairs of contrasting characters of garden bee for his breeding experiments. In F1 generation, Mendel got all tall plants for monohybrid cross. In F2 generation, all plants were not tall and 1/4 of them were short. With such crosses, law of dominance and law of purity of gametes which is also called law of segregation, was worked out. In dihybrid cross, Mendel got the ratio of 9:3:3:1 in F2 generation. This led to discovery of law of independent assortment. Genes are made up of DNA, which forms proteins responsible for expression of characters. In human beings, sex of individual is genetically determined. Human beings have 23 pairs of chromosomes. 23rd pair is known as sex chromosome. Women bear XX type of sex chromosomes, while men are with XY type of sex chromosomes. Thus, men are with 44 plus XY combination, and women are with 44 plus XX combinations of chromosomes. Variations are the structural, functional, or behavioral changes from the normal characters of the living organisms.
Introduction. Light is something that everyone is familiar with. It comes from many sources, the main one being our sun, and it provides us with the energy needed for life. Without it, life as we know it would not exist. The form of energy which helps us to see objects is called light. Objectives. At the end of this lesson, you'll be able to define light, understand the nature of light, understand the reflection of light by a plane mirror, laws of reflection, differentiate between real and virtual image, light and its sources. The form of energy which helps us to see objects is called light. Light travels in straight line. It causes in us the sensation of sight. There are two sources of light: luminous objects and non-luminous objects. Luminous objects. The objects which emit their own light are called luminous objects. Example: sun, lamp, candle. Non-luminous objects. The objects which reflect the light which falls on them are called non-luminous objects. Example: moon, chair, etc. Nature of light. To know how light reflects, refracts, diffracts, and many other aspects, we have to understand the nature of light by its theories. The nature of light has two theories: wave theory of light and particle theory of light. Wave theory of light. Light consists of electromagnetic waves which do not require a material medium for its propagation. Its characteristics features are diffraction, interference, and polarization. Particle theory of light. Light is composed of particles which travel in a straight line at a very high speed. Its characteristic features is reflection and refraction. Light exhibits the properties of both waves and particles. Light has dual nature. Reflection of light. The sending back of light rays when it falls on the surface of an object is called reflection of light. Objects having polished surface reflect more light than the objects having unpolished, dull surfaces. Silver is the best reflectors of light. Reflection from plane surfaces. Plane mirror is a thin, flat, and smooth sheet of glass having a shining coating of silver metal on one side. The silver coating is protected by red paint. Meaning of important terms are as follows to understand the figure. Incident ray. The ray of light which falls on the mirror surface is called the incident ray. Point of incidence. The point at which the incident ray falls on the mirror is called the point of incidence. Reflected ray. The ray of light which is sent back by the mirror is called the reflected ray. Normal. The normal is a line at right angle to the mirror surface at the point of incidence. It is a line which is perpendicular to the mirror at the point of incidence.
Lateral inversion. When an object is placed in front of a plane mirror, then the right side of the object appears to become the left side of image, and the left side of the object appears to become the right side of image. This change of sides of an object and its mirror image is called lateral inversion.
Characteristics of an image formed by a plane mirror. The image formed is virtual. It cannot be received on a screen. The image formed is erect. The size of the image is as of the object. The image formed by the plane mirror is at the same distance behind the mirror. The image formed is laterally inverted, sideways reversed. Uses of plane mirror. They are used to see ourselves. They are fixed on the inside wall of certain shops like jeweler's shop to make them look bigger. Plane mirrors are used in making periscopes. They are used at blind turns of busy roads to prevent accidents. Plane mirrors are used as looking glass. They are used in solar cookers. They are used to make kaleidoscope, a toy which produces beautiful patterns from colored paper, pieces of glass, or small colored beads. Laws of reflection. First law of reflection. The incident ray, the reflected ray, and the normal all lie in the same plane. Second law of reflection. The angle of reflection is always equal to the angle of incidence. Difference between objects and images. Object. Anything which gives out light rays is called an object. Images. Image is an optical appearance produced when light rays coming from an object is reflected from a mirror. Difference between real and virtual images. Real images. The images that can be obtained on the mirror are called real images. Example. Images formed on a cinema screen. It is formed by a concave mirror. Virtual images. The images that cannot be obtained on a screen are called virtual images. Example. Image of our face in a plane mirror. It is formed by concave lens. Did you know? Visible light has wavelength in a range from about 380 nanometers to about 740 nanometers, with a frequency range of about 405 terahertz to 790 terahertz. Light which is emitted and absorbed in tiny packets, called photons, exhibits properties of both waves and particles. This property is referred to as the wave-particle duality. The speed of light in a vacuum is defined to be exactly 29 crores 97 lakhs 92,458 meter per second, that is 3 into 10 raised to the power 8 meter per second. Mechanisms that can produce light. Scintillation, electroluminescence, sonoluminescence, triboluminescence, Cherenkov radiation. Summary. Let us summarize what you have learned. Light is a form of energy which enables us to see objects. Light exhibits the properties of both waves and particles. Hence, light has dual nature. The process of sending back of light rays which falls on it is called reflection. The change in direction of light when it passes from one medium to another is called refraction. The angle of incidence is the angle made by the incident ray with the normal. The angle of reflection is the angle made by the reflected ray with the normal at the point of incidence. The angle of incidence is equal to the angle of reflection. Image is formed when the light rays coming from an object meet at a point after reflection from a mirror. In plane mirrors, there is the effect of reversing the sides of an object, and its image is called lateral inversion. Introduction. As we look around the room, we see most objects by the light reflected from them in order to converge to bring the parallel rays of light closer, or diverge to spread out the parallel rays of light. This phenomenon of converging and diverging is done by spherical mirrors. The mirrors having curve-like surfaces are known as curved mirrors. Objectives. At the end of this lesson, you'll be able to define spherical mirrors, understand the types of spherical mirrors, understand the reflection of light by spherical mirrors, concave mirrors and convex mirrors, differentiate between concave and convex mirrors, how to form images, know the sign convention for mirrors, define magnification. Introduction of curved surface. A spherical mirror is that mirror whose reflecting surface is the part of a hollow sphere of glass. Spherical mirrors are of two types: concave mirror and convex mirror. Concave mirror. A spherical mirror in which reflection takes place at the bent in surface is called concave mirror. Convex mirror. A spherical mirror in which reflection takes place at bulging out surface is called convex mirror. Important terms to understand spherical mirrors. Center of curvature. It is the center of the hollow sphere of glass of which the mirror is the part. Pole. The center of a spherical mirror is called the pole. Principal axis. The straight line passing through the center of curvature and pole is called principal axis. Aperture of the mirror. The portion of mirror where reflection of light takes place is called aperture of the mirror. Principal focus. The point on the principal axis to which all the light rays are parallel and converge after reflection is called the principal focus. Focal length. It is the distance between the pole and the principal focus. Rules for obtaining images formed by concave mirrors. Relationship between the radius of curvature and focal length is F is equal to R upon 2. Rule 1. A ray of light which is parallel to the principal axis passes through its focus and after reflection from the mirror. Rule 2. A ray of light passing through the center of curvature reflects back along the same path. Rule 3. A ray of light passing through the focus then becomes parallel to the principal axis after reflection. Rule 4. A ray of light incident at the pole is reflected back making the same angle with the principal axis. Formation of different types of images by concave mirror. When object is placed between pole P and focus F, image is formed behind the mirror, virtual and erect, larger than the object, magnified. When object is placed at the focus F, image is formed at infinity, real and inverted, highly enlarged. When the object is placed between focus F and the center curvature C, image is formed beyond center of curvature, real and inverted, larger than the object. When object is placed at the center of curvature C, image is formed at the center of curvature C, real and inverted, same size. When object is at infinity, image is formed at focus, real and inverted, smaller than the object. Uses of concave mirror. Concave mirror are used as reflectors in torches, vehicles, headlights, and searchlights. Shaving mirrors to see large images of the face. Dentists to see large images of the teeth of patients. Rules for obtaining images formed by convex mirror. Rule 1. A ray parallel to the principal axis of a convex mirror appears to be coming from the mirror. Rule 2. A ray going towards the center of curvature of a convex mirror is reflected back along the same path. Rule 3. A ray going towards the focus of a convex mirror becomes parallel to the principal axis after reflection. Rule 4. A ray incident at the pole is reflected back making the same angle with the principal axis. Every time the image has following characteristics. The image is formed behind the mirror. It is virtual and erect, smaller than the object. Formation of different types of images by convex mirror. When object is at infinity, image is formed behind the mirror. It is virtual and erect, smaller than the object. When object is placed anywhere between pole P and infinity, image is formed behind the mirror. It is virtual and erect, smaller than the object. Uses of convex mirror. Convex mirrors are used as rear view mirrors in vehicles to see the traffic at the rear side because it always produces erect image. The size of image is small and so we can see a wide field of view of traffic behind. Mirror formula and calculations. Mirror formula is the relationship between the image distance v, object distance u, and focal length f. 1 upon v plus 1 upon u is equal to 1 upon f, where u is the distance of object from mirror, v is the distance of image from mirror, f is the focal length of the mirror. Sign convention for spherical mirrors. All the distances are measured from pole. Distances are measured in the same direction of the incident light is taken positive. Distances against the direction of incident light is taken negative. Distances measured upward and perpendicular are taken positive. Distances measured downward and perpendicular are taken negative.
Refraction of light. The speed of light changes when light rays travel from one medium to another medium. In this process, light rays bend when they pass at an angle from one medium to another. This phenomenon is called refraction of light. Refraction of light can occur by two ways: rarer to denser medium. When light rays travel from a rarer to a denser medium, then velocity of light decreases in the denser medium. Hence, light rays bend towards the normal. Denser to rarer medium. When light rays travel from a denser to a rarer medium, then velocity of light increases in the rarer medium. Hence, light rays bend away from the normal. The refractive index. The speed of light in different substances varies. Therefore, different substances have different abilities to bend or refract light. This bending ability of a material is known as the refractive index of that material. Refractive index of a medium is the ratio of velocity of light in vacuum to its velocity in a given medium. The refractive index of a rarer medium is less as compared to that of a denser medium. Laws of refraction. There are two laws of refraction. First law, the incident ray, the refracted ray, and the normal to the surface separating the two media at the point of incidence all lie on the same plane. Second law, the ratio of sine of angle of incidence to the sine of angle of refraction is a constant for a given pair of media. This law is also known as Snell's law. Sin I upon sin R is equal to mu, where mu is a constant called refractive index. Snell's law is not applicable when the ray is incident along the normal. Refraction through a rectangular glass slab. Consider a rectangular transparent slab made of a material of refractive index n. Let a ray of light PQ enter from air at Q. This ray is refracted at the upper surface of the glass slab and moves along QR within the slab. At R, it gets refracted again and emerges into the air. By Snell's law, at point Q, n is equal to sin I upon sin R. At point R, n is equal to sin E upon sin R. From equation 1 and 2, we get sin I upon sin R is equal to sin E upon sin R. This gives I is equal to E. Therefore, when a ray of light passes through a transparent slab with parallel faces, the emergent ray is parallel to the incident ray, but it is displaced. This displacement is proportional to the thickness of the slab. Refraction by spherical lenses. Lenses produce images similar to those formed by curved mirrors, but they do so by refracting light. Lenses are either convex or concave in form. Convex lenses are thickest at the middle. Concave lenses are thickest around the edges. Most lenses are made of glass and have spherical surfaces. Light rays passing through a convex lens bend towards the principal axis, whereas rays passing through a concave lens bend away from the principal axis. The rays passing through the convex lens converge to a point F. The rays passing through the concave lens diverge as if traveling outwards from a point F. F is the principal focus of the lens, and the distance from F to P is called the focal length. Rules to draw ray diagrams for spherical lenses. Rule number 1. A ray of light through the optical center of the lens, O, passes undeviated through the lens. Rule 2. A ray of light parallel to the principal axis passes through F when it leaves the lens. Rule 3. A ray of light through F' leaves the lens parallel to the principal axis. Formation of images by convex lens. When the object is placed at infinity and the rays are parallel to the principal axis, then the image formed at principal focus on the other side. The nature of the image is real, inverted, and diminished. When the object is placed at infinity and the rays are not parallel to the principal axis, then the image formed at the focal plane on the opposite side of the lens as that of object. The nature of the image is real, inverted, and highly diminished. When the object is placed beyond 2f, then the image formed on the opposite side between f and 2f. The nature of the image is real, inverted, and diminished. When the object is placed at 2f, then the image formed at 2f on the opposite side. The nature of the image is real, inverted, and same size. When the object is placed between 2f and f, then the image formed beyond 2f on the opposite side. The nature of the image is real, inverted, and enlarged. When the object is placed at f, then the image formed at infinity. The nature of the image is real, inverted, and enlarged. When the object is placed between f and the optical center, then the image formed on the same side. The nature of the image is virtual, erect, and enlarged. Formation of images by concave lens. When the object is placed at infinity, then the image formed at f on the same side. The nature of the image is virtual, erect, and diminished to a point. When the object is placed at any distance, then the image formed on the same side between optical center and f. The nature of the image is virtual, erect, and diminished. Sign convention for spherical lenses. The sign convention rules are as follows. Rule number 1. All distances are measured from optical center. Rule number 2. Distance measured in the direction of incident light is positive and distance measured against incident light is negative. Rule 3. Distances measured above the principal axis are positive and distances measured below the principal axis are negative. Rule 4. According to sign convention, focal length of a convex lens is positive and that of the concave lens is negative.
Magnification produced by lenses. The ratio of the height of image to the height of object is known as linear magnification. Magnification is equal to height of image h2 upon height of object h1. M is equal to h2 upon h1, which is equation 1. If magnification has plus sign, image formed is virtual and erect. If magnification has minus sign, the image formed is real and inverted. The linear magnification is equal to the ratio of the image distance to the object distance. M is equal to V, image distance, upon U, object distance, which is equation 2. Equating equation 1 and 2, h2 upon h1 is equal to V upon U. Note, in mirrors, linear magnification is M is equal to minus V upon U, and of lenses is M is equal to V upon U. Power of lenses. The power of a lens is measured by the degree of convergence or divergence of light rays falling on them. Convex lens converges the beam of light falling on it and focusing them to the optical center, it has the greater power. Concave lens diverges the beam of light falling on it and making it less strong. Power of lens. The power of a lens is defined as the reciprocal of its focal length in meters. Power of lens is equal to 1 upon focal length. Important points. The power of convex lens is positive. The power of concave lens is negative. Power of combination of lenses. If a number of lenses are placed in close contact, then the power of the combination of lenses is equal to the algebraic sum of the powers of individual lenses. P is equal to P1 plus P2. The SI unit of power of a lens is diopter. It is denoted by the letter D. Did you know light exerts physical pressure on objects in its path? Light pressure is equal to the power of light beam divided by c, the speed of light. It is written in the Rig Veda that light consists of 3 primary colors. Mixing the 3 colors, they have produced all the objects of sight. Summary. Let us summarize what we have learned. In concave mirror, the reflection takes place in the bent-in surface. In convex mirror, the reflection takes place from the bulging out surface. The radius of curvature of a spherical mirror is the radius of the hollow sphere of glass of which the mirror is the part. The focus of a convex mirror is situated behind the mirror. The image is formed at that point where at least 2 reflected rays intersect. A real image is always inverted and virtual image is always erect. Large concave mirrors are used in the field of solar energy to focus sun's rays for heating solar furnaces. The object distance u is always negative in mirrors. A medium in which the speed of light is more is known as optically rarer medium.
Introduction. Out of all the 5 sense organs, eye is the most important organ of our body. It is because of eyes that we are able to see and appreciate the amazing world around us. Our eyes makes us see the colors of the world. Objectives. At the end of this lesson, you'll be able to understand working of human eye, know defects of vision and their correction, understand the refraction of light through prism, understand the dispersion of white light by a glass prism, know atmospheric refraction and its applications, know scattering and its applications, the human eye and its working. Our eyes makes us see the colors of the world. Human eye has a crystalline lens and it works like a camera. Various parts of eyes along with their functions are cornea. It is the transparent bulge on the front surface of eyeball. Light enters the eyes through cornea. Iris. It is a thin and circular diaphragm behind cornea which controls the size of the pupil. Pupil. It is a hole in the center of iris that appears black and controls the amount of light entering in the eyes by shrinking or expanding. Retina. It is a delicate membrane which acts as a screen. The eye lens forms a real and inverted image of the object on retina. Power of accommodation. Human eye lens has the ability of increasing or decreasing the focal length. It is known as the accommodation. Accommodation is achieved with the help of ciliary muscles. There is a limit up to which focal length of eye lens can be adjusted. Far point. The maximum distance up to which we can see a distant object clearly. To see a distant object clearly, ciliary muscles relax to make the eye lens thin. Near point. The least distance at which objects can be seen clearly without any strain. To see a nearby object clearly, ciliary muscles contract to make the eye lens thick. Defects of vision and their correction. Eye may lose its power of accommodation due to some refractive defects. There are 3 such defects. Myopia or nearsightedness. In this type of defect, a person is not able to see the far-off objects clearly. The image of the object is formed in front of retina. It is caused either due to elongation of eyeball or due to excessive curvature of eye lens. To correct this defect, concave lens is used because its diverging power. so that it directs the light rays on the retina for image formation. Hypermetropia and its correction. In this type of defect, a person cannot see nearby objects clearly. In this case, focusing of light rays by eye lens takes place behind retina. It is caused either due to increase in focal length of eye lens or due to decrease in size of eyeball. To correct this defect, a convex lens can be used which converges the light rays on retina, and hence image formation takes place and the person can see the nearby object clearly. Presbyopia and its correction. In this type of defect, a person is neither able to see a distant object nor a nearby object clearly. This defect is a result of weakening of ciliary muscles and decrease in flexibility of eye lens with age. To correct this defect, person has to wear a bifocal lens having concave lens in upper part and convex lens in lower part. Refraction of light through a prism. Refraction is the bending of light as it travels from one medium to other. In this section, we shall discuss the phenomenon of refraction by a glass prism. A prism is a solid figure having two triangular bases and three rectangular surfaces. Angle between each surface is known as the angle of prism. A ray of monochromatic light is made to incident on a glass prism, bends towards the normal at the air-glass interface, then travels straight and bends away from the normal at glass-air interface. The emergent ray and the incident ray are at an angle known as angle of deviation. Dispersion of white light by glass prism. Now we shall discuss what will happen if we incident white light on the glass prism. As white light is made to fall on a glass prism, it gets split into 7 colors: violet, indigo, blue, green, yellow, orange, red. This phenomenon is known as dispersion of white light. Reason of dispersion. White light consists of 7 different frequencies which correspond to a different color. Angle of deviation for each color is different, because of which each color bends at a different angle and we see a band of colors known as Vigbio. Recombination and rainbow. Recombination. Isaac Newton observed that if he keeps 2 glass prisms parallel to each other such that one is inverted with respect to other, then white light entering into one prism gets split into 7 colors, which when fall on other prism recombine to give white light again. This is termed as recombination. We all love to see the lovely view of rainbow after the rains. It is a natural phenomenon which occurs as a result of dispersion. A rainbow is always seen opposite to the sun in the sky. During rain, water drops act as prisms for the sunlight. Water drops refract, disperse, and then internally reflect the sunlight to give the rainbow. Atmospheric refraction and its applications. Our atmosphere is not uniformly dense at any local place. Depending on the local condition, it may have hot and cool air near the ground. Hot air is lighter than cooler air and hence has lesser refractive index than cooler air. Due to this starlight or sunlight entering, the atmosphere undergoes refraction. This is known as atmospheric refraction. As light coming from stars passes through the atmosphere towards the normal and the apparent position of star is seen above the real position of star. Also, the starlight keeps on wavering because of dynamic nature of atmosphere and hence stars appear to be twinkling. For us, sunrise occurs when sun is above the horizon. When sun is below horizon, sunlight entering the atmosphere gets refracted due to difference in density of the atmospheric layers. Because of this, sun is seen above the horizon and we see the sunrise 2 minutes before sun actually reaches horizon. Similarly, sun sets for us 2 minutes late because of atmospheric refraction only. Scattering of light and its applications. As light passes through the atmosphere, gets spread by dust particles or other air molecules. This is termed as scattering of light. The color of light scattered depends on the size of the scattering particle. Tyndall effect. When a light is made to fall on a colloidal solution, it gets scattered by the colloidal particles and hence the path of light becomes visible. This is termed as Tyndall effect. Like in a dark room, when a hole is made and light is allowed to pass through it, then we are clearly able to see the path of light as well as the dust particles which otherwise are not seen in the air. Following are the examples of scattering of light. Color of sky. As the sunlight passes through the atmosphere, the blue light gets scattered more than any other color, as the wavelength of blue color is just optimum for getting scattered by the finer particles of atmosphere. So blue color reaches us and we see sky blue. That means if Earth has no atmosphere, then the sky will appear black. Color of sun during sunrise and sunset. At sunrise or sunset, sunlight travels the maximum distance. So the blue color having shorter wavelength gets scattered and only red colors reaches us, being longest wavelength. So the sun appears red at sunrise and sunset. Did you know? A human being has a horizontal field of view of about 150 degree with one eye and of about 180 degree with two eyes. The twinkling of a star is due to atmospheric refraction of starlight. The sun is visible to us about 2 minutes before the actual sunrise and about 2 minutes after the actual sunset because of atmospheric refraction. The pupil can increase its size also under the effect of strong emotions. The blue-eyed ones see better than the brown-eyed ones. The iris color has no link with the visual sharpness. The human eye sees basically three colors: red, green, and blue. These are basic colors. The white is a combination of the three. The black is their lack. Yellow, purple, or mauve form through the combination of two basic colors. These are called secondary colors. Dogs can't see the difference between the colors red and green. The average person blinks 12 times per minute, about 10,000 blinks in an average day. The eye is the only part of the human body that can function at 100% ability at any moment, day or night, without rest. It is impossible to sneeze with your eyes open. The space between your eyebrows is called the glabella. Under the right conditions, the human eye can see the light of a candle at a distance of 14 miles. People generally read 25% slower from a computer screen than from paper. Summary. Let us summarize what we have learned. Human eye has a crystalline lens and it works like a camera. Various parts of eye are pupil, cornea, iris, crystalline lens, and retina. Human eye lens has the ability of increasing or decreasing the focal length. It is known as the accommodation. Cataract is an eye disease in which eye lens loses its transparency, due to which partial or total loss of vision may take place. It can be treated by a surgery. A prism is a solid figure having two triangular bases and three rectangular surfaces. Angle between each surface is known as the angle of prism. As white light is made to fall on a glass prism, it gets split into 7 colors: violet, indigo, blue, green, yellow, orange, red. This phenomenon is known as dispersion of white light. Recombination is the phenomenon which is opposite to dispersion. Refraction of light as it passes through different layers of atmosphere is termed as atmospheric refraction. Tyndall effect. When a light is made to fall on a colloidal solution, it gets scattered by the colloidal particles and hence the path of light becomes visible. Scattering. As light passes through the atmosphere, gets spread by dust particles or other air molecules.
Introduction. Rita, I have placed immersion rod and bucket to heat water. Do not go near it.
I wanted to ask you about this. How can electricity heat water or cook food, such as in an electric cooker that you use to cook rice?
This is all because of heating effect of electricity. Let me explain you this. Children, in this lesson, you will learn about electric current, electric circuits and effects of electric current. Objectives. At the end of this lesson, you will be able to define electric current and circuit, Identify the potential and potential difference. Describe the circuit diagram. Explain Ohm's law. Identify the factors on which the resistance of a conductor depends. Describe the resistance of a system of resistors. Explain the heating effect of electric current and electric power. Electric current and circuit. All things around us are made up of atoms. Each has three particles: protons, neutrons and electrons. Electrons spin around the center of the atom and have a negative charge. Protons are in the center of atoms and have a positive charge. An electric current is created when electrons move through a conductor. There are two types of currents: direct current, DC. A current that flows in one direction is called a direct current or DC. For example, a battery produces a direct current. Alternating current or AC. A current that flows back and forth is called an alternating current or AC. The symbol of electric current is I. Electric potential and potential difference. Let us look at the concepts of electric potential and potential difference. Electric potential. Electric potential is a scalar quantity denoted by E or V. It is a point equal to the electric potential energy of a charged particle at the location divided by the charge of the particle. Electrical potential difference. Electrical potential difference determines the direction of the flow of charge. For example, consider a pipe connected to a container through a stop cock. The quantity of water in the pipe is less than the quantity in the container. However, the level of water is higher in the pipe than the level in the container. When the stop cork is opened, the water begins to flow from the pipe to the container till the levels of water in both the pipe and the container are equal. This determines that it is not the quantity of water but the level of water which decides the direction of flow of water. It is the potential difference that is responsible for the flow of water. Did you know? The I symbol was used by André Marie Ampère. The unit of electric current is named after him when he formulated the eponymous Ampere's force law discovered in 1820. Circuit diagram. A schematic diagram is easy to represent an electric circuit. There are conventional symbols that you can use to represent most of the elements used in the circuit diagram. The symbols are shown. Ohm's law. Ohm's law deals with the relationship between voltage and current. It states that the current through a conductor between 2 points is directly proportional to the potential difference across the 2 points. Factors on which the resistance of a conductor depends. There are 3 external factors that influence the resistance in a conductor. They are thickness, length, temperature. There is a 4th factor that influences the resistance, and that is the conductivity of the material. This, however, is considered an internal factor rather than an external one. Thickness. The cross-section area of a conductor or thickness can be compared to the cross-section of a hallway. If the hall is wide, it allows a high current through it. In case of a narrow hall, it would be difficult for the current to get through. This is due to the cross-sectional area that restricts the high rate of flow. Length. The length of a conductor is similar to the length of the hallway. A shorter hallway allows movement at a higher rate than a longer one. Temperature. The temperature of a conductor does not have less effect on the resistance of the conductor. The higher the temperature, the higher is the resistance. For example, when you turn on a light bulb at the first instance, the wire is cold and has a low resistance. But as the wire heats up, it gives off light and increases the resistance. Did you know? When you double the length of a wire, you double the resistance of the wire, whereas when you double the cross-sectional area of a wire, you cut the resistance in half. Resistance of a system of resistors. A resistor is known as a passive two-terminal electrical component that represents the electrical resistance as a circuit element. The current passing through a resistor is directly proportional to the voltage across the resistor's terminals. Thus, resistance is the ratio of the voltage applied across a resistor's terminals to the intensity of current through the circuit.
Combination of resistors. Combination of resistors are of two types.
They are resistors in series and resistors in parallel. Resistors in series. Resistors that are connected in series, where the current flows through them one after another, are known as resistors in series. Here, the current depends on the applied voltage, the number of components, and the nature of components in the circuit. Resistors in parallel. Resistors that are connected such that they branch out from a single point and join up again somewhere else in the circuit are known as resistors in parallel. Here the current through each component is the same as if it were the only component present. So the total current flowing through the battery is the sum of the currents flowing through each branch. Did you know? For resistors in series, the current is the same for each resistor, whereas the resistors in parallel, the voltage is the same for each one. Heating effect of electric current. The heating effect of electric current is widely used today. This effect is caused when electric current is passed through a conductor. This generates heat due to the resistance it offers to the current flow. The work done in overcoming this resistance produces heat. The heat produced by a heating element is directly proportional to the square of the electric current passing through the conductor, the resistance of the conductor, the time for which current passes through the conductor. It is defined as H is equal to
I square root
RT and is known as Joule's law. Practical applications of Joule's law. The heating effect of electric current can be applied to many appliances. These include electric immersion water heater, electric iron box. A good heating element has a high resistivity and a high melting point. For example, an electric fuse is an example of heating effect of electric current. The rating given as 3A of an electric fuse states that the maximum current it can sustain is 3 ampere. Electric power. Electric power is the rate at which electric charge is transferred by an electric circuit. This is commonly known as electric power. The following are the components associated with electric power. The International System of Units, SI, defines the unit of electric power is watt, W. It is known as the power consumed by a device that carries 1 A of current when used at a potential difference of 1 V. Watt is very small unit. In actual practice, a much larger unit called kilowatt is used. This unit is equal to 1000 watts. The unit of electric energy is watt-hour, WH, as electrical energy is the product of power and time. The commercial unit of electric energy is kilowatt-hour, kWh, commonly known as unit. Did you know? Electric current is also used in nature. Natural examples include lightning, the solar wind, and the sources of the polar auroras. Summary. Let us summarize what we have learnt. An electric current is created when electrons move through a conductor. A current that flows in one direction is called a direct current. A current that flows back and forth is called an alternating current. Electric potential is a point equal to the electric potential energy of a charged particle at the location divided by the charge of the particle. Electric potential difference determines the direction of the flow of charge. Ohm's law states that the current through a conductor between 2 points is directly proportional to the potential difference across the 2 points. 3 external factors influence the resistance in a conductor: thickness, length, and temperature. A resistor is known as a passive two-terminal electrical component that represents the electrical resistance as a circuit element. Resistors that are connected in series, where the current flows through them one after another, are known as resistors in series. Resistors that are connected such that they branch out from a single point and join up again somewhere else in the circuit are known as resistors in parallel. Electric power is the rate at which electric charge is transferred by an electric circuit.
Introduction. Dad, I'm looking at this compass you bought me for my birthday. It is such a good device. But something happened and I'm unable to figure why that has happened. Can you help me, Dad? Yes, Rajiv. Tell me exactly what happened. I took the compass to my friend's place. They have some electric work being done in their house. We were playing with the compass very close to an open wire. Suddenly, for no reason, the compass needle got deflected. When we moved away from the wire, it came back to where it was. Why did that happen? That happened because electric current acts like a magnet and produces a magnetic effect. Children, in this lesson, we will learn about magnetic fields, electromagnetic effects, electric motors, and electric generators. Objectives. At the end of this lesson, you'll be able to identify magnetic fields and field lines, describe the force on a current-carrying conductor in a magnetic field, explain an electric motor, explain electromagnetic induction, describe an electromagnetic generator, identify domestic electric circuits, overview of magnetic fields and field lines. A magnetic field is created by the magnetic influence of an electric current and magnetic material. Our planet Earth produces its own magnetic field, which is an important factor during navigation. Magnetic fields are also used in electric devices such as transformers. Magnetic field lines can be compared to the constant altitude lines that are visible on a map. Magnetic field lines help in stating simple concepts of magnetism easily. These are defined as the number of field lines through a surface. These can be easily transformed into a mathematical format. Magnetic field lines are visually displayed in polar auroras, where visible streaks of lines are created along the direction of Earth's magnetic field. Current-carrying conductor. An electric current passing through a metallic conductor results in a magnetic field being created around it. The charge of the current-carrying conductor placed in a magnetic field experiences a separation in a direction that is perpendicular to the current and the magnetic field. This results in a voltage whose direction is proportional to the applied magnetic field. This effect can also be reversed. Magnetic field. Current through a straight conductor. As you have seen earlier, let us see what happens when we change the current that is passing through the wire. The effect on the compass also varies. So, if you increase the current, the deflection of the needle of compass will increase. From this we know that the magnitude of the magnetic field produced at any given point will increase as the current through the wire increases. Now try moving the compass away from the current passing through the wire. You will see that the magnetic field produced by a given current in the conductor decreases as the distance from the compass and the wire increases. Maxwell's corkscrew rule. Maxwell's corkscrew rule, also known as right-hand thumb rule, defines that moving a corkscrew in the direction of current moves the direction of magnetic field along with the direction of current vertically downwards. If we move the corkscrew downwards in the direction of current and the handle of corkscrew is turned in the clockwise direction, then the direction of the magnetic fields is in the clockwise direction. So, when current flows upwards, the direction of magnetic field changes and is anti-clockwise. Magnetic field. Current through a circular loop. Let us now look at what happens when the wire through which we passed the current is placed in a circular manner. The magnetic field around it is generated in the form of concentric circles. Try moving the bar magnet away from the wire slowly. By the time we reach the center of the loop, the concentric circles appear as straight lines. The entire magnetic field appears as a straight line. Now try applying Maxwell's corkscrew rule to this and check whether every section of the wire is able to generate magnetic field lines in the same direction. Magnetic field. Current in a solenoid. A solenoid is a current-carrying wire that is coiled closely into a shape of a cylinder with the turns as close together as possible. This is similar to a bar magnet. Each solenoid has a north pole and south pole. The magnetic field lines inside a solenoid are straight lines and indicate that the magnetic field is similar at all points in the solenoid. This strong magnetic field in the solenoid can be used to magnetize magnetic materials. This type of a magnet is called an electromagnet. Force of current-carrying conductor. We have seen that an electric current that flows through a conductor produces a magnetic field. The magnetic field so produced exerts a force on a bar magnet placed close to the conductor. French scientist André-Marie Ampère, 1775 to 1836, discovered that the bar magnet would also exert an equal and opposite force on the conductor. Fleming's left-hand rule. Fleming's left-hand rule is mnemonic to represent 3 directions. You need to stretch your thumb, forefinger, and middle finger of your left hand. Each finger points to a specific direction. The forefinger points in the direction of the magnetic field. The middle finger points to the direction of the current. The thumb points to the direction of the motion. This is Fleming's left-hand rule. Examples include woofers, subwoofers, electrical actuators, etc. Electric motor. An electric motor is an electromechanical device. It converts electrical energy into mechanical energy. Let us look at how electric motors work. A motor uses magnets to create motion. Inside an electric motor, the attracting and repelling forces of a magnet create rotational motion. Fans, blowers, and pumps, disc drives, etc. are some examples of electric motors. Electromagnetic induction. The production of an electric current across a conductor moving through a magnetic field is called as electromagnetic induction. For example, generators, transformers, induction motors, electrical motors, synchronous motors, and solenoids all use electromagnetic induction. Michael Faraday was a British scientist, chemist, physicist, and philosopher who discovered the magnetic field, electromagnetic induction, diamagnetism, and electrolysis. His experiments included the discovery of generating currents by moving a magnet. Let us try sliding a bar magnet in and out of a coil of wires. You see that the wires generate a current. This is known as electromagnetic induction. Electric generator. An electric generator converts mechanical energy to electrical energy. It forces electrical charge to flow through an external electrical circuit. Examples include a water pump, which causes water to flow but do not create water. Electric generators operate based on electromagnetic induction, that is, whenever a conductor moves to a magnetic field, a current is induced in this conductor. If a magnet is spinning inside a coil, alternating current is induced in the coil. Alternating current changes direction after equal intervals of time. The other type of current is direct current, which does not change direction with time. Domestic electric circuits. Electric power is generated far away from the places it is consumed. At the generating station, the electric power is generated at 11,000 volts with an alternating voltage frequency of 50 Hz. The power is transmitted to the places of consumption at high voltage to reduce the loss of energy during transmission. The electric power line enters our house through 3 wires, namely the live wire, red wire, the neutral wire, black wire, and the earth wire, green plastic insulation. The live wire has a high potential of 220 volts and the neutral wire has 0 potential. Thus, the potential difference between the live wire and the neutral wire is 220 minus 0, which equals 220 volts. There are different circuits used for different appliances being used in the house. The earth wire is connected to a metal plate deep into the earth to avoid receiving any severe shock in case of any leakage of current while using the appliances. A fuse is an important of all circuits. It ensures that there is no damage that occurs to any appliances in case of current overloading. Overloading occurs when the live wire and the neutral wire come in contact with each other or there is a rise in the supply voltage. In this case, the fuse prevents the circuit and the appliance from damage by stopping the flow of electric current. Did you know? Unlike the field of a bar magnet, the Earth's magnetic field changes as time goes by because it is generated by the motion of molten iron alloys in the Earth's outer core. Fleming's left-hand rule is used for electric motors and Fleming's right-hand rule is used for electric generators. Separate hands need to be used for motors and generators because there is a difference between the cause and effect of both the motors and generators. Summary. Let us summarize what we have learned. How magnetic field and field lines are generated. The force on a current-carrying conductor in a magnetic field. What is an electric motor and how it works? What is electromagnetic induction and what are its uses? What is an electromagnetic generator and how it works? The use of wires and fuse in domestic electric circuits.
Introduction.
Can anybody tell me what happens when we keep a bowl full of petrol open in a room? The petrol will evaporate, teacher. That is correct. You see that the energy generated by petrol is evaporated in the environment, but in a form that is not usable. However, if we use the same petrol in our bike, the petrol is converted into an energy source that is usable.
Children, in this lesson, we will learn about the conventional sources of energy and the non-conventional sources of energy and its impact on the environment. Objectives. At the end of this lesson, you will be able to identify conventional sources of energy, identify the non-conventional sources of energy, describe the environmental consequences, explain the duration of the energy sources. A good energy source. In your day-to-day life, you need a lot of energy throughout the day. All physical activities that you perform require energy. Also, this energy comes from a source that would give you the required energy to perform any activity. You need to keep in mind that any good energy source must assist you in performing a large volume of work, be easily available, be easy to store and move from one location to another, be affordable. Conventional sources of energy, fossil fuels. Fossil fuels are generated by natural processes. They include a high percentage of carbon. These are non-renewable sources of energy as they take millions of years to form. The reserves of these fuels are reducing at an alarming rate. The types of fossil fuels are coal, petroleum, natural gas, heavy crude oil. Conventional sources of energy, thermal power plants. A thermal power plant is an industry where energy is generated by steam. Here, water is heated and then it is turned into steam. This in turn spins a steam turbine, driving an electrical generator. After it passes through the turbine, the steam is condensed in a condenser and recycled to where it was heated. Conventional sources of energy, hydropower plants. Hydropower plants generate electricity from the energy of falling water. Hydropower is a renewable source of energy. The advantages of hydroelectricity are: the cost of hydroelectricity is low. Hydroelectric power supply is more suitable for industrial applications. No carbon dioxide is produced as no fossil fuels are burnt. Did you know? Burning fossil fuels generates around 21.3 billion tons, 21.3 gigatons of carbon dioxide, CO2, per year. Natural processes can only absorb about half of that amount. As you can see, there is a net increase of 10.65 billion tons of atmospheric carbon dioxide per year. Biomass. Biomass is a renewable energy source and is generated from biological material that is derived from living or recently living organisms. As an energy source, it is either used directly or converted into other energy products such as biofuel. For example, forest residues such as dead trees, branches and tree stumps, yard clippings, wood chips and even municipal solid waste. Biomass also includes plant or animal matter that can be converted into fibers or other industrial chemicals. Wind energy. Wind power is the conversion of wind energy into a useful form of energy, using wind turbines to make electricity, windmills for mechanical power, wind pumps for water pumping or drainage, or sails to propel ships. A large wind farm consists of several hundred individual wind turbines that are connected to the electric power transmission network. Offshore wind farms harness more frequent and powerful winds than are available to land-based installations. They have less visual impact on the landscape, but construction costs are considerably higher. Small onshore wind facilities provide electricity to isolated locations, and utility companies increasingly buy back surplus electricity produced by small domestic wind turbines. Did you know? All large wind turbines have the same design, a horizontal axis wind turbine with an upwind rotor with 3 blades, attached to a nacelle on top of a tall tubular tower. In a wind farm, individual turbines are interconnected with a medium voltage power collection system and communications network. At a substation, this medium voltage electric current is increased in voltage with a transformer for connecting to the high voltage electric power transmission system. Alternate energy sources. As we progressed, our day-to-day life activities also changed. We now get most of our work done by machines. Due to this, we need to look for alternate sources of energy, as our natural resources are not sufficient to provide for the energy in our machines. Examples include solar energy, energy from the sea, geothermal energy, nuclear energy. Solar energy. Solar energy is derived from the radiant light and heat of the sun. It has been used by humans since ancient times for a range of technologies. Solar energy is used for architecture and urban buildings. Solar energy is also used for heating water in our day-to-day life, where the solar hot water systems use sunlight to heat water. In low geographical latitudes, the domestic hot water usage is provided for with temperatures up to 60 degrees Celsius by solar heating systems. The most common types of solar water heaters are evacuated tube collectors and glazed flat plate collectors, generally used for domestic hot water, and unglazed plastic collectors used mainly to heat swimming pools. Energy from the sea. Tidal energy. Tidal energy is a form of hydropower that converts the energy of tides into electricity. This is a renewable source of energy. Tidal energy is extracted from the oceanic tides. Tidal forces are periodic variations in gravitational attraction exerted by the moon. This force creates motions or currents in the oceans. Due to the strong attraction to the oceans, the water level rises. This leads to the water from the middle of the ocean to move towards the shorelines, creating a tide. This is an unfailing occurrence due to the consistent pattern of the moon's orbit around the Earth. The energy generated by the tide is saved by constructing a dam on a narrow opening to the sea. A turbine is then fixed at the opening of the dam that converts this tidal energy to electricity. Energy from the sea. Wave energy. Wave energy is the generation of energy by oceanic waves. We can capture this energy to do useful work, for example, electricity generation, water desalination, or the pumping of water into reservoirs. Waves are generated by wind passing over the surface of the ocean. As long as the waves move slower than the wind speed above the waves, there is an energy transfer from the wind to the waves. Both air pressure differences between the upwind and the wave crest, as well as friction on the water surface by the wind, makes the water undergo shear stress that causes the growth of the waves and in turn helps in generating wave energy. Energy from the sea. Ocean thermal energy. Ocean thermal energy uses the temperature difference between cooler deep surface and warmer shallow surface ocean waters to run a heat engine and produce useful form of energy, mainly electricity. The heat engine gives greater efficiency and power when it is run with a large temperature difference. In the oceans, the temperature difference between surface and deep water is greater in the tropical areas, and other areas it is a modest 20 to 25 degrees Celsius. After the surface water is sufficiently warm, it is used to boil volatile liquid ammonia. The vapors of ammonia are then used to run a turbine. The cold water is then pumped from the depths of the ocean and is used to condense the ammonia vapor back to the liquid. Did you know? The Earth receives 174 petawatts of solar radiation at the upper atmosphere. Approximately 30% is reflected back to space, while the remaining 70% is absorbed by clouds, oceans, and land masses. Geothermal energy. Geothermal energy is thermal energy generated and stored in the earth. Molten rocks are formed in the deeper hot regions of Earth's crust. Heat conducts from the Earth's core to the surrounding cooler rock. The high temperature and pressure causes some rock to melt. This heats the rock and water in the crust, sometimes up to 370 degrees Celsius. Geothermal energy is used for hot springs and space heating. Nuclear energy. Nuclear energy uses sustained nuclear fission to generate heat and electricity. It is a sustainable energy source that reduces carbon emissions. Nuclear energy is generated by a process called nuclear fission. In this process, the nucleus of heavy uranium, plutonium, or thorium is bombarded with low-energy neutrons. This atom is then split into lighter nuclei. A tremendous amount of energy is released. For example, the fission of an atom of uranium produces 10 million times the energy produced by the combustion of an atom of carbon from coal. Environmental consequences. Using any source of energy affects the environment around us. Therefore, before exploiting any energy source, ensure that it does not disturb the environmental balance and is harnessed judicially. Renewable sources of energy last for as long as they keep generating, whereas non-renewable energy runs out. We have to be judicious in our selection of energy, the purpose of the energy being used, and the actual usage of the energy. Summary. Let us summarize what we have learnt. Using a good source of energy is advantageous. Conventional sources of energy include fossil fuels, thermal power plants, and hydropower plants. The conventional sources of energy improved with the use of biomass and wind energy. Solar energy, energy from the sea, geothermal energy, and nuclear energy are all alternate sources of energy. Renewable sources of energy last for as long as they keep generating, whereas non-renewable energy runs out. We have to be judicious in our selection of energy, the purpose of the energy being used, and the actual usage of the energy, so as to avoid affecting the environment around us. Introduction. Have you ever been to the bank of River Yamuna in Delhi?
No, ma'am.
Yes, ma'am, I have been there once, but ma'am, there is a very unpleasant smell in the river and it is extremely dirty. Yes, Gaurav, you are absolutely correct. Yamuna River is now one of the most polluted rivers of India, but it was clean before. Have a look. And now our activities have made it polluted and it appears dirty. How are we making this river polluted? Many of our activities destroy the clean state of rivers, such as throwing plastic bags, pollution from the cars, dumping of industrial wastes. Let us explore them in detail and their effects on our environment. Objectives. At the end of this lesson, you will be able to define the term environment and list its living and non-living factors, discuss the concept of ecosystem, its components and groupings of biotic components, form a series of organisms feeding on one another, food chains and webs, elaborate on how human-made activities influence our environment. Ecosystem. An ecosystem is a natural system consisting of all plants, animals and microorganisms in an area functioning together with all the non-living physical factors of the environment. Components of ecosystem. Ecosystem comprises the following two components. 1. Biotic factors including all living organisms. 2. Abiotic factors that includes physical factors such as sunlight, temperature, chemical factors such as mineral content, soil moisture, etc. Types of ecosystem. There are two different types of ecosystems. They are 1. Natural ecosystem, in which we have forests, deserts, grasslands, mountains, etc. and 2. Artificial ecosystem, in which, example, parks, gardens, crop fields, zoo, etc. exists. Classification of biotic components of ecosystem. Biotic components of our environment can be classified into three major groups. They are producers, consumers, and decomposers. Now we will learn in detail that what are producers, consumers, and decomposers. Producers are organisms like green plants that produce organic compounds from inorganic compounds. A consumer is the organism that obtains nutrients from other organisms. And the decomposer are microorganisms which decompose dead plants and animals. They decompose complex organic substances into simple inorganic substances in the soil, which are again used by the plants. Food chain. A food chain is a succession of organisms in an ecological community that constitutes a continuation of food energy from one organism to another as each consumes a lower member and in turn is preyed upon by a higher member. A food chain begins with a producer. Producers are eaten by primary consumers, herbivores, which are eaten by secondary consumers, carnivores, some of which may in turn be eaten by tertiary consumers, the top carnivore in the chain. Trophic levels. Each step in a food chain where transfer of food energy takes place is called trophic level. The first trophic level consists of producers. The second trophic level consists of primary consumers. The third trophic level consists of secondary consumers. The fourth trophic level consists of tertiary consumers. Since the transfer of food energy decreases at every trophic level, the number of trophic levels are limited and do not exceed 4 or 5. Trophic levels. Energy flow in trophic levels of a food chain. Green plants producers absorb about 1% of solar energy falling on the leaves and stores. During the transfer of food energy from one trophic level to the next, 90% of the energy is lost to the environment and only 10% is transferred to the next trophic level. So, there is a decrease in the amount of food energy transferred at every trophic level by 10%. This is known as the 10% law of energy transfer. Biomagnification. Harmful chemicals like insecticides and pesticides, which are used to protect crops from insects and pests, are absorbed by plants and enter the food chain. Since these chemicals are non-biodegradable, they get accumulated at every trophic level and their concentration increases. Since human beings occupy the highest trophic level, the concentration of these harmful chemicals is maximum in our bodies. The increase in concentration of harmful chemicals in the bodies of organisms at higher trophic levels is called biological magnification. Food web. The complex system of interrelated food chains in an environment is known as food web. How do human activities affect the environment? Human activities produce a lot of waste materials which are thrown away into the environment. These wastes cause pollution of air, water and soil. The waste materials produced are of two main types. They are biodegradable waste and non-biodegradable waste. The household waste is called garbage. Garbage causes pollution of air, water and soil, so it should be disposed properly. Some of the methods of garbage disposal are landfills, recycling, production of biogas and manure, preparation of compost, incineration, sewage treatment. Depletion of ozone layer in the atmosphere. Ozone molecule contains 3 oxygen atoms, O3, At higher levels in the atmosphere, the UV radiation splits some oxygen molecules O2 into free oxygen atoms, which combine with oxygen molecules O2 to form ozone. The ozone layer present in the higher layer of the atmosphere protects the Earth from the harmful UV radiation from the sun. UV radiation causes skin cancer in humans. The ozone layer is being damaged by the use of chemicals like chlorofluorocarbons, CFCs, used in refrigerators and fire extinguishers. So the use of CFCs is now being reduced to protect the ozone layer. Assessment. Time for an activity now. Drag and drop the organisms in the correct positions to complete the following aquatic food chain. Did you know? Montreal Protocol was established in 1987 on the substances that deplete the ozone layer. It is an agreement that has successfully reduced the global production, consumption, and emission of ozone-depleting substances. Summary. Let us summarize what we have learnt. An ecosystem comprises of the interactivities between its biotic and abiotic components. Biotic components of ecosystem comprises of producers, consumers, and decomposers. The series of organisms taking part at various biotic levels form a food chain. There is continuous loss of energy as we move from one trophic level to another trophic level of a food chain. Waste generated can be classified into biodegradable and non-biodegradable wastes. The use of chemicals like CFCs is causing ozone depletion.
Introduction. The management of natural resources to meet people's requirements has been practiced since the pre-Vedic era. Farmers were ranked high in the social system, and village management was in their hands. In order to manage land, water, and vegetation, technical knowledge suitable to the specific conditions of a region was required. They gained this knowledge and developed skill through experience and learning by doing. Overexploitation of natural resources by growing population resulted in various severe problems. Destruction of vegetation has resulted in land degradation, denudation, soil erosion, landslides, floods, drought, and unbalanced ecosystems. A balanced ecosystem is an urgent need. Environmentally aware consumers are producing less waste by practicing the 3 R's: reduce, reuse, and recycle. They are buying products that are less toxic or contain less packaging, using reusable containers and other reusable items, maintaining and repairing products, participating in recycling programs, and buying products made from recycled materials. Objectives. At the end of this lesson, you'll be able to express the necessity of resources, explain the distribution of forests, wildlife, and their sustainable management, describe the method of rainwater harvesting, identify the importance of fossil fuels like coal and petroleum. Why should we manage our resources? Not surprisingly, exploration and development of our natural resources has spin-off benefits, especially in construction, manufacturing, and professional, scientific, and technical services. Most of the growth in the economy comes from natural resources like diamonds, oil, and gas especially. And the linkages between the resource activity and other sectors, such as retail trade, are not as strong as they could be. While this growth is good news, it means that much of the natural resources are being used off. There are some resources which cannot be replaced, so it is our duty to take proper care of them. Forests and wildlife. The forest is a complex ecosystem consisting mainly of trees that have formed a buffer for the earth to protect life forms. The trees which make up the main area of the forest create a special environment which in turn affects the kinds of animals and plants that can exist in the forest. The FAO, Food and Agriculture Organization, has defined forest as land with tree crown cover or equivalent stocking level of more than 10% and area of more than 0.5 hectare. The trees should be able to reach a minimum height of 5 meters at maturity. In the tropical and subtropical region, forests are further subdivided into plantations and natural forests. Natural forests are forests composed of indigenous trees not deliberately planted. Plantations are defined as forest stands established by planting and seeding in the process of afforestation or reforestation. There are about 16 major types of forests in India, from the tropical type to the dry type. Forests can develop wherever there is an average temperature greater than about 10 degrees Celsius in the warmest month and an annual rainfall in excess of about 200 mm annually. In any area having conditions above this range, there exists an infinite variety of tree species grouped into a number of stable forest types that are determined by the specific conditions of the environment there. Forests can be broadly classified into many types, some of which are the taiga type, consisting of pines, spruce, etc., the mixed temperate forests with both coniferous and deciduous trees, the temperate forests, the subtropical forests, the tropical forests, and the equatorial rainforests. In India, it is believed that organized exploitation of forest wealth began with an increase in hunting. Ashoka the Great is said to have set up the first sanctuary to protect the forests and all life in it. The Mughal rulers were avid hunters and spent a great deal of time in the forests. It was during the British rule that the first practical move towards conservation in modern times took place. They established reserved forest blocks with hunting by permit only. Though there were other motives behind their move, it at least served the purpose of classification of and control over the forests. Sustainable management. Forests are rich and complex ecosystems which support biodiversity, provide valuable ecological services, and have considerable potential for tourism. In particular, millions of poor people depend on forest ecosystems for food, water, fuel, fiber, and both timber and non-timber products, indeed for their very survival. To achieve sustainability, there must be a rethinking of what we consider a basic need. It is common in our society to say that we need a given resource, but how much of it do we really need to use? Also, how do we decide what the basic needs of our ecosystem and the organisms living within it are? Defining what constitutes a basic need is perhaps the greatest challenge to adopting sustainable practices in our daily lives, as interpretations of need vary widely from region to region, village to village, and even from person to person. While ecologists are usually averse to putting a price on what is considered invaluable, the people argue convincingly that by not considering the economic benefits of forests, their conservation status is actually undermined because their diverse economic contributions remain largely unrecognized or undervalued. Water. Water, as we all know, is one of the basic necessities of all life forms. We all know that it is the greatest gift of God to us. Water is naturally replenished by precipitation and naturally lost through discharge to the oceans, evaporation, and subsurface seepage. Although the only natural input to any surface water system is precipitation within its watershed, The total quantity of water in that system at any given time is also dependent on many other factors. These factors include storage capacity in lakes, wetlands, and artificial reservoirs, the permeability of the soil beneath these storage bodies, the runoff characteristics of the land in the watershed, the timing of the precipitation, and local evaporation rates. All of these factors also affect the proportions of water lost through discharge to the oceans, evaporation, and subsurface seepage. Human activities can have a large impact on these factors. Humans often increase storage capacity by constructing reservoirs and decrease it by draining wetlands. Humans often increase runoff quantities and velocities by paving areas and channelizing stream flow. Rainwater harvesting. Over the years, rising populations, growing industrialization, and expanding agriculture have pushed up the demand for water. Efforts have been made to collect water by building dams and reservoirs and digging wells. Some countries have also tried to recycle and desalinate water. Water conservation has become the need of the day. The idea of groundwater recharging by harvesting rainwater is gaining importance in many cities. In the forests, water seeps gently into the ground as vegetation breaks the fall. This groundwater in turn feeds wells, lakes, and rivers. Protecting forests means protecting water catchments. In ancient India, people believed that forests were the mothers of rivers and worshipped the sources of these water bodies. This has become a very popular method of conserving water, especially in the urban areas. Rainwater harvesting essentially means collecting rainwater on the roofs of building and storing it underground for later use. Not only does this recharging arrest groundwater depletion, it also raises the declining water table and can help augment water supply. Rainwater harvesting and artificial recharging are becoming very important issues. It is essential to stop the decline in groundwater levels, arrest seawater ingress, that is, prevent seawater from moving landward, and conserve surface water runoff during the rainy season. Coal and petroleum. Coal is by far the most abundant fossil fuel on Earth. It is essentially carbon and is mainly used as combustion fuel. The large-scale use of coal began with the Industrial Revolution in the 19th century. As the number of industries increased, demand for more sources of energy grew. Coal is the product of plants, mainly trees that died tens or hundreds of millions of years ago. Due to waterlogging in low-lying swampy areas or in slowly sinking lagoons, dead trees and plants did not decompose as they normally would. The dead plant matter was covered with water and protected from the oxidizing effect of air. The action of certain bacteria released the oxygen and hydrogen, making the residue richer and richer in carbon. Thick layers of this carbon-rich substance, called peat, built up over thousands of years. As more material accumulated above the peat, the water was squeezed out, leaving just carbon-rich plant remains. Pressure and temperature further compressed the material. This aided the process of producing coal as more gases were forced out, and the proportion of carbon continued to increase. The carbon slowly metamorphosed into coal over millions of years. Petroleum is found in porous rock formations in the upper strata of some areas of the Earth's crust. Known reserves of petroleum are typically estimated at around 1.2 trillion barrels, with at least one estimate as high as 3.74 trillion barrels. Consumption is currently around 84 million barrels per day or 31 billion barrels per year. Because of reservoir engineering difficulties, recoverable oil reserves are significantly less than total oil in place. At current consumption levels, current known reserves would be gone in about 32 years, around 2039. However, this ignores any new discoveries, changes in demand, better technology, population growth, industrialization of third world countries, and other factors. While oil is expected to remain a major source of energy in coming years, alternative energy development such as solar power, wind power, butanol, ethanol, photovoltaic, nuclear power, hydrogen, or oil from oil shale and oil sands may increase in significance. Coal may also increase in use because of its existence in vast quantities in rapidly developing countries such as China and India, which are exempt from controls under the Kyoto Protocol. 3 R's: reduce, reuse, and recycle. Reduce unnecessary waste by avoiding pointless purchases. Items that are rarely get used can be borrowed or shared with others. Buy bottles instead of cans and rechargeable batteries. Reuse items that you would normally consider as rubbish because sometimes it could be used for other purposes. Instead of throwing items away, reduce waste by using them for other purposes. Paper and envelopes can be used as scrap paper for making notes. Recycle the waste products from which you can conserve some amount of energy. Make sure you have a recycle bin at your home. Keep it in an obvious place so that you will not forget to use it. Summary. Let us summarize what we have learned. Most of the growth in the economy comes from natural resources like coal, oil, and gas especially. The forest is a complex ecosystem consisting mainly of trees that have formed a buffer for the earth to protect life forms. The FAO, Food and Agriculture Organization, has defined forest as land with tree crown cover or equivalent stocking level of more than 10% and area of more than 0.5 hectare. In the tropical and subtropical region, forests are further subdivided into plantations and natural forests. Ashoka the Great is said to have set up the first sanctuary to protect the forests and all life in it. The British established reserved forest blocks with hunting by permit only. Water is naturally replenished by precipitation and naturally lost through discharge to the oceans, evaporation, and subsurface seepage. Rainwater harvesting essentially means collecting rainwater on the roofs of buildings and storing it underground for later use. Coal is the product of plants, mainly trees, that perished tens or hundreds or millions of years ago.